Hello, everyone, and welcome. Thank you for joining us today for this live stream event. My name is Albena, and I'm the program manager of the Microsoft Reactor San Francisco. I will be sharing session resources with you in the chat, but before we begin, I would like to quickly review two items with you: our code of conduct and our event guidelines. First, please take a moment to review our code of conduct. Microsoft Reactor seeks to provide a respectful environment for both our audience and presenters. We do encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. And secondly, our event guidelines. This session is being recorded and will be available on demand through the Microsoft Reactor YouTube channel in about 24 to 48 hours. And now I'm inviting our speakers, Pamela Fox and Mustafa Branch. Hello.
Hey, how's it going?
Hi, everyone.
All right, so thank you everyone for joining us. My name is Mustafa. I'm a developer audience product marketing manager here at Microsoft. I'm also someone who uses Python myself. So I build a lot of things, sometimes useful, sometimes not so useful. I've been using Python for a couple of years now and a lot more in the last few months. So super excited for the session today. I'm going to learn something from this session. I'll be coding along with you guys. In the chat, we also have Dawn, who's a cloud advocate. She's really awesome, and she'll be there to answer some of your questions if you have them. So please, you guys are already doing great at it, but hop in the chat, ask questions. If you need us to double click on anything, make sure you just drop it in there, and we'll be looking in there constantly. So we'll make sure to get all your questions answered. This will kind of be the first of a few Python-related sessions we'll be doing through the Reactor. So you'll also see some surveys in the intermittent slides after each session. If you can just pop in there, completely anonymous. I'll be reading the results myself. Just ask you, what are you looking to learn from the next session? How many years of experience do you have? Just things like that so we can make sure we're putting out the right content. And with that, I'll hand it over to Pamela. Thank you so much, Pamela. Super excited for the session.
All right. Hello, everyone. So excited to see everyone is already saying where they're from and saying hello in the chat. And we have a pretty big day ahead of us here. For those of you, I know people are from all over, so I don't know how long people are sticking around, but we're going to have 3 sessions. So the first one, we're going to be talking about API, specifically FastAPI and deploying that on Azure. Then we're going to talk about database, Postgres, Django, and deploying that on Azure. And then finally, we're going to talk about how to containerize using Docker and putting that on Azure Container Apps. So we will have these 3 sessions. The first one's at 9:30 PT right now. Then we'll have a 10-minute break and start at 11:10 a.m. PT for the next one. And then the final one is actually at 12:50 p.m. PT. So we'll be finishing up around like 2:20 PT. That's the plan. So we're covering a ton. So thank you for already being here and bringing your enthusiasm to the chat. So who am I? I am a Python cloud advocate at Microsoft. And what does that even mean? That means that I help Python developers figure out how to use Azure, which is Microsoft's cloud. So figuring out how to deploy Python apps on Azure, figuring out how to use, Python with Viz Code, all the things about being a Python programmer and working with Microsoft products. Before being at Microsoft, I was teaching at UC Berkeley. I taught a Python class. It was Python, Scheme, SQL, and BNF. We taught quite a bit in that class, but it was mostly a Python class, and that's where I got really deep into Python. It was really fun. I was also one of the first engineers at Coursera. So I've always loved educational technology because I like teaching. I was also at Khan Academy, where I created most of the computer programming courses. So the JavaScript, HTML, CSS, SQL courses. If you've ever gone through those, that's my voice. And my very first job was at Google, where I was working on the Maps API, which was super fun. And you can tweet at me, toot at me, GitHub at me, whatever form of contact you prefer. Here's all my contact details here. So then the question is, who are all of you? And people are already sharing in the chat where they're from. So that's great. That helps us see that we have this global community tuning in here. There's Python programmers from all over the world. Also curious, what do you do? Why are you interested in Python? Are you new to Python? Have you been doing Python for 20 years? Whatever you want to share in the chat, that's awesome because it helps us, see who's tuning in and get a better feel for the audience. I'm pretty sure we have a big spectrum of people tuning in today. And so some of the stuff I might talk about, you might already know, you might be an expert at, which is totally cool. So if you already know something, then, answer questions in the chat, share your knowledge, share tips, that sort of thing. But if you're brand new to something, then, some of the stuff might be, completely new, which is awesome too. So just remember, we have a spectrum of people tuning in today. And we're just here to, support each other, learning new things. That's the whole goal, right? Is just to learn new things all the time because there's so much stuff to learn in technology all the time. That's why I like it. Cool. So I see people are now also sharing what they do, and that is great. So whenever I look over, I'm looking at the chat there. All right. Very cool. So keep sharing that. That's awesome. Okay, so in this first session, we're going to talk about HTTP APIs, which are near and dear to my heart since my very first job was about APIs. Then how to build these APIs using FastAPI, which is the #1 framework for doing that. And it's probably like the most popular Python framework these days, or the hot new thing at least. And then how we would host that API on Azure. All right, so now let's talk about HTTP API. So API stands for Application Programming Interface. It is a way for one program to talk to another program. There's many different kinds of APIs. So even when we're using Python's URL lib module, we're basically using its API, right? We're talking to the URL lib. It's like a contract. So, this program says, hey, this is the way you communicate with me. As long as you communicate with me that way, then I'll give you the information you want. All right, so we have a contract between two programs. So for example, here, if we had a weather module with a forecast function, we can use its API to find out today's forecast. So that's an API just, within a single program. Now, what's more interesting and what we're going to talk about today is an HTTP API. So that's an API that uses HTTP as its communication protocol. So everything on the web goes over HTTP. So when you load a web page, you're making HTTP requests to a server and getting back responses with the web page contents. So when you use an HTTP API, you're making a request to a server using the HTTP protocol and getting back some data. So here I have the weather example here, but this time it's over HTTP. So we asked, to get the forecast for some zip code, and then we get back this response. And in this case, it gives us back a JSON response that says the weather for today. The most popular format these days is JSON. In the past, the most popular format was XML. So shout out in the chat if you remember the days of XML, especially if you remember SOAP. My dad was actually a huge SOAP evangelist. And because of that, I didn't like SOAP because he tried to get me to use it. But fortunately, we've moved past that. And most APIs use JSON. We use some JSON schema to define what it looks like. But JSON stands for JavaScript Object Notation. If any of you have done some JavaScript, you'll recognize it. But we now have JSON support in all languages because it has become this standard format for communicating. So yeah, but you could also, I actually did use an XML API on Azure the other day, and it doesn't look that different. It's just more verbose and it has a lot more angle brackets. And also, if you ever are parsing a blog feed, that's typically going to be XML, a specific schema of XML, RSS or Atom. So XML definitely does crop up, and all languages pretty much have support for parsing XML too. You can also be interacting with an image API. I love image APIs. They're so fun. I make a bunch of them for fun now too. So you could be requesting, give me an image of what the weather looks like, and you would get back, a PNG or a GIF or something like that. I see a lot of discussion of XML in the chat. Yeah, XML definitely has its uses, so I shouldn't actually say it. But I was personally very overwhelmed by the vast number of SOAP standards, and that's what I didn't really like very much. But XML certainly does have its uses, and JSON is not perfect either. None of these are perfect, but they're just good to know. So when using an API, you could be doing a GET request, or you could be doing a POST request. So GET is when you're retrieving data from a server, and we often use GET requests with query parameters. So here you can see like /weather zip equals 94530. So that's a way that we're customizing our request. It's like passing arguments into a function. So we're passing our argument of the zip code. POST is when you send data to a server. So this is super important if you're have an API where you're sending, any sort of private user data, any sort of data, really, you're going to want to use a POST to put that data in the body of the request and then send it over an HTTPS connection. And that's going to be much more secure than anything in the query parameters. You should assume that anything you put in your query parameters, somebody could do a, man in the middle attack and, sniff that out. So it's much safer to do POST over a secured connection. Now, when you post data, you could post it with a variety of formats. You could post JSON, and that is very popular these days since JSON is just very popular. You could post it as a form encoded, like I've done here. And that's what happens by default when you submit a form on the internet. It's doing a post to a server, encoding the fields like this. And you could post XML. You could post anything. As long as the server knows how to receive it, then you could, you just have to agree with the server. APIs are just agreements. They're just contracts. So the API says, this is what I accept, and then you send it that. Okay, so first let's look at actually, before we make an API, let's look at how we process an API in Python, because I always get asked this actually. So let's say we have an API. So there's this Zipopotamus API. And this one, you pass it a zip code and it gives you back information about that zip code. So you can see some information here. If anybody wants to try it on your zip code, just put your zip code in the chat if you feel comfortable, but no pressure. So here we have this zip code API here. So let's say that I wanted to parse this in Python. All right, so I have here a Python 3.11 environment. So I'm just going to make a little Python script. Make sure this is big enough for everyone to see. All right. Okay, so how can I parse it? All right, so we could use the built-in Python URL lib module, but there's a third-party module that's actually really nice called URL lib3, and it recently had a new release, so I thought it'd be fun to celebrate by using URL lib3. So here we go. I've installed URL lib3, and then I can import it here. And then let me remind myself how to actually use URL lib3. So I'll just copy and paste that. All right. So we say URL lib3.request, and we say the verb we're using, get or post. So here we're going to do a get, and here's the URL that we're going to fetch. Oh, and I see some recommendations for zip codes. So we'll try this one. So it does a get request to that URL, and then we get the result. And this is a JSON API, so I'd immediately tell URL lib to convert that text of the body of the request of the response into JSON, and then I'll just print the result. Let's see what it looks like. Okay, so here we see some JSON in here. Let me see if I can make this even bigger. All right, we see some JSON. I want to show you another really cool package. It's called the Rich package. So holler if you've used this before. I only just discovered this. It is beautiful. So I'm going to install Rich and then import Rich. And then instead of doing print, I think I just do rich.print. Let's try this out. Yes, look at this. So Rich just knows how to how to pretty print everything. So it knows how to pretty print dates and JSON and numbers and all sorts of things. So here we can see the JSON pretty printed, and now we can actually look at it and see what's in the results here. So if we wanted to parse this JSON, what we could do, because it's coming back as a Python dict. This is actually a Python dictionary, right? So if we do want to parse it, like we want to get the lat long out, we could say lat equals, and I'll just use the Copilot suggestion. So I'll use Copilot today in order to go through things a bit faster. So here you can see result places, which is a list, and then we get the latitude, and then result places, the first one, and we get the longitude. So that should give us the lat and long. Let's just try that out and confirm that we got lat and long. Okay, here we go. Very nice. Now what we could do is we could try passing that to the sunrise sunset API, and we can find out when the sunrise and sunset is for that zip code. So this is generally how we make requests to the sunset API. So I'm going to do a get. All right. And I'll just do an F string. And I'm going to put lat here and then put long here. And we'll get it in time zone. So that's UTC. The time zone on the Eastern Coast, EST, if I remember correctly, Eastern Standard Time. Yeah. All right. And then let's try that out. All right, so here we see that now we know what the sunrise and sunset is for that zip code. If you're the one that lives in that zip code, then, confirm that you did see, you woke up at 4:56 a.m. today and saw the sunrise. And then here's when your sunset's going to be. All right, so that's just an example of interacting with APIs to get us a feel for, what it's like to be the consumer of an API. And now that can give us, maybe more motivation when we're actually creating an API ourselves. All right, let's see. Good questions in the chat. I see there's some questions about API design. I love that question, right? How do you design a good API? Like, what should the query parameters be? How do you do versioning? So when I was at Google on the Maps API, we spent so much time trying to figure out how to come up with a good versioning scheme. Because on the one hand, you don't want to accidentally break developers, but on the other hand, you want people to constantly be getting the new stuff. And yeah, we spent a lot of time trying to figure out what is the optimal versioning scheme. And there's other debates as well as to, like, do you use query parameters, do you use cookie parameters, do you use header parameters? So lots of good things to think about when designing an API. Here's some example of popular APIs. And let's see. So we've got a good question too. Is there a PyPy style list for APIs out there? Gosh, I don't know if there's a style list for APIs. So we are going to be using, FastAPI is going to use OpenAPI. So there's certainly a standard for how to declare your API schema, right? So these APIs, they might have API schemas using the OpenAPI schema. That's definitely a standard. But within that standard, there's a lot of flexibility, right? There's lots of places you could put your parameters. You could put them in cookies and or path or query or whatnot. So I don't know if I've seen something that specifically is more prescriptive than how to describe your API. But that's a really good question. If anybody knows, please share anything in the chat. One thing I will share is a style guide for documentation. So if you are making a public facing API, then I recommend that you consider the, I don't even know how to pronounce this, the diataxis framework. I'm sure I didn't pronounce that right. I'm not even sure which, it comes from Greek. I don't speak ancient Greek. But if you are creating public documentation, this framework just talks about, the different axes of documentation. So you want to have all of these things for good documentation, right? You want tutorials, you want reference, you want how-to guides. It'll just serve different users, different use cases. I've seen some great APIs that have amazing how-to guides, but then have no reference. And then I've had to like actually grep through the code on GitHub in order to figure out, just the parameters of a particular function. So this is one thing to keep in mind in terms of how you document an external facing API, even an internal API. So lots of people these days are making internal APIs, right? Just as the way to make a web app. You have your front end and then you communicate with your back end. So even for internal APIs, communicating with your colleagues, how do you let your colleagues know how to use the API? So check that out. That one's really cool. So some examples of APIs here, if you're looking for inspiration from existing APIs, consider different types of APIs. So there's APIs that deal with just general data that's not specific to a user. So the Microsoft Translator API, if you want to translate from one language to the other, I have an app that uses that. The Movie Database API has lots of movie information. Open Weather API is similar to the one we were just playing with as a mock API. So there's lots of cool APIs like that provide data. And, that can give an example of how to do that. There's also lots of APIs that deal with user data. So these are APIs that make it possible for users to interact with their data that's usually stored in some app, some user interface, to interact with a different way, right? So like social media, the classic ones, Twitter API, which is now too expensive for most people to use. But if somebody wanted an alternate way of posting to Twitter, they could use the API if they could afford it. There's also Facebook, Instagram API, right? These are all enable users to have more flexibility for interfacing with a service, and it can often make it more likely for someone to become a powerful user of a service, or even a user at all, right? Sometimes somebody won't use a service if it doesn't have APIs to be able to, interact with it in different ways. And then there's productivity software. So Google Workspace APIs, Microsoft Graph APIs. That's if you want to interact with stuff like stored in drives and docs, online documents, that sort of stuff. I've done a lot of work with online spreadsheet APIs and being able to manipulate online spreadsheets in different ways. Now, pretty much all of these APIs require you to sign up for a key, an API key. And that's really important to the API provider because that way they can track usage and they could limit calls. And they often have pricing levels, right? So some of these APIs might be free, but most of them will have pricing tiers, which is like, okay, sign up for a key and you can, start at the free level. But then if you want, this many calls, then you need to pay this amount. If you want, this many calls, you're going to have to pay this amount. If you want a huge number of calls, then you have to talk with our enterprise team. We had that level at Google, I remember. So most of them will have tiers, but sometimes the tiers aren't based on usage. Sometimes it's based off your type of usage. So I remember at Google, it was always free. When I worked on it, it was always free if your map was publicly shown on a public website. You only had to pay when it was used internally, right? So if it was used for an internal trucking application or used for some internal intranet application that no one could see. So definitely, when you're considering using an API, take a very careful look at their terms of use, their pricing plans, what determines whether you get to use something at the free tier, all the limitations, and also keep in mind what your backup plans are. Unfortunately, a lot of APIs do die or they change their pricing, like the Twitter API. So I've personally worked on many APIs that no longer exist, and it's very, very sad. So APIs can be really amazing, but it is also good to have a backup plan. And also keep that in mind if you're going to make an API, how long are you going to keep that API going if it's going to be a public API? Okay, so let us go now and build an API. Well, let me just first see if we had any more questions. I see there's some excitement about, alternatives to Twitter APIs with Blue Sky. And I think Mastodon, you can also build on top of Mastodon with the ActivityPub protocol. So maybe lots of people porting things over from Twitter right now. And yeah, Discord has an API. So making bots is a really big use of APIs. At Google, I also worked on Google Wave. So shout out to anybody who remembers Google Wave. I was actually in charge of the API server, the developer server that was just for developers to play with APIs. And we had really cool APIs to make Wave robots and also Wave gadgets. And they were very fun. And they were probably very similar to Discord and Slack APIs today. All right, so let's go ahead and build an HTTP API. So we are going to use FastAPI. You could use many frameworks to make an API in Python. You could use anything. I've used Flask. I've used API Flask. There's something called Sonic. There's a lot of options out there, but we are going to use FastAPI today because it is the most popular one and it's really fun. It is called FastAPI because it's both fast to build and fast to execute. It is built on top of asynchronous Python. And that does mean that it can be faster in some cases, depending on your setup. It does rely on Python type hints. So if you haven't used Python type hints or type annotations, this is your chance to use them. And that's how it figures out what the types of the API are going to be. And we'll see that soon. It auto-generates the documentation, which I friggin' love. Because remember, I was at Google where we handcrafted our Google Maps documentation. We had so much, we put a lot of effort into figuring out how to do auto-generated documentation as well, but a lot of it was handcrafted. But these days, there are all these libraries that can auto-generate documentation based off of open API specs, which is what FastAPI does. So FastAPI figures out what your open API spec is going to look like, makes that spec, and then uses the Swagger UI package in order to turn that into documentation. So we'll see what that looks like. Okay, so let's start building. If you do want to follow along, there is a repo here that you can start with. And so here you'll see the short link for it and then the long link. So feel free to follow along. Let me actually, more information about following along, since this is our first session of the day here. If you do want to follow along, I expect most people won't just because you probably just want to watch, but you can also follow along. We totally welcome that. So 3 options that I'd recommend. I think the easiest is using Github Codespaces. That works as long as you have a GitHub account. And it's just the easiest because it requires the least amount of setup. You just have to wait for the code space to load. Option 2 is to use VS Code locally. And if you're using VS Code, I do recommend using Docker Desktop and the dev containers extension because I've created a dev container for all of these repos to make them work better so that you don't have to do much setup, so that everything's already set up with the right Python version and packages and everything. So that is the recommended local development option. Or option 3, local, just whatever. Whatever you use locally, if you got Python 3, should be able to make it work, but it might be a little more effort to get things installed. Make sure you make a Python virtual environment as a best practice always. So those 3 options for following along. And as I was saying, I do recommend Codespaces. It is a way that you can have an online development environment for any repo you find on GitHub. So it's a great way, like if you see a GitHub repo and there's something you want to fix, but you're like, oh, I don't want to check it out locally, you can just go to the repo and let me show it. Let me open up a repo and show you how it works. We're going to go here and let's see, it was this one. And I go to the repo, I click code, and it shows this Codespaces tab. And then I click create Codespace on main. So it creates a Codespace on the main branch. And then you click it and it does, the worst part is this part. When you click it, it does take maybe 3 minutes to build. It depends on the environment and how much stuff is inside it. So at that point, that's when I, watch YouTube videos, just watch people singing on YouTube usually. So that's the only downside of Codespaces. It takes some time to build, but once it's built, you can keep using that Codespace, and it'll be fast to load the next time you load it up. So link to the repo. Let me go back and give the link to the repo here. So it's aka.ms/fastapi-starter. If someone could post that in the chat. Let me see if I can do it. Ready? aka.ms/fastapi-starter. Here we go. All right. So if those of you who do want to follow along, we'll be on that repo. Okay, so we are done with this one. And I think this is the one I want. So I already started it earlier, so now it should be pretty fast to start back up. But it still will take like 30 seconds or so. And today I am using a blue theme just to match my slides. I actually usually use a light theme, but that seems to cause some controversy. I'm using a blue theme today. Everyone can share your favorite theme in the chat. Okay. So here we go. Let's load it up. Let me make it bigger. All right. So what do we have here? So we've got a requirements.txt. And if we look inside here, we see that the requirements are FastAPI and also Unicorn, which I'll explain soon. And then we have an API folder, which has main.py. So here is the beginning of our FastAPI app. This is a random name generator. If you want your name added to this name generator, post it in the chat. And yeah, so this is useful because, well, I have two daughters, and I used a lot of name generators. So I can always use more name ideas. So how does this work? Since it's a random name generator, we do start with importing random. Then we import FastAPI. Then we construct a FastAPI app. And then we define a route. So this is the only route in this particular API. We could define lots and lots of routes. This one currently only has one route. We could add more later. So we say that this route is responding to GET requests. So you see it says GET. So that means it is responding to a GET request. And it responds at this path here, /generate name. And then we have the function. So it has a list of names. And then it picks using random.choice, it picks a random name, and then it returns back a Python dictionary, which has a key of name and a value of random name. So let's go ahead and run this and see what happens, because it's pretty cool to see all the stuff that FastAPI does with this pretty small amount of code. How do we run this? All right, so we're going to run it using Unicorn. So Unicorn is a production level server that can run asynchronous Python frameworks. So we can use it to run FastAPI. As you see here that FastAPI, we see the async in front of the def. So we need to use a web server that understands how to handle asynchronous functions. And Unicorn is the most typical one used. So I'm going to paste, and since I'm in a code space, I do have to allow it access to my clipboard the first time I do that. All right, so I'm pasting, and what we have here is a command that calls Unicorn on api.main:\app. So it's going to look inside the API folder, find the main file, and then find the app variable inside of it. So we're telling Unicorn, here's the synchronous application that you should be using. We're telling it we want it to reload. This is when we're developing locally. We want this reload functionality so that we can make changes and have it auto reload. You wouldn't want this on production, just locally. And then we tell it which port it's going to expose the API on. So we'll just go with 8000 here. All right. So now we have application running on port 8000 is available. So notice that Codespace automatically popped this up and let me know. We could also check this ports tab here in Codespaces, and it'll show us which ports are running. So we can try this out here. Okay, And you'll see this really, if it works, this is what you'll see. I know this doesn't look amazing, but this is actually what it'll look like if it works, because there's nothing, we didn't define anything for the root URL, right, for slash. So you get this not found. That's what FastAPI defaults to. But what does exist is, if we do slash generate name, then we see the JSON response. So the first thing I'm going to point out is that here we returned back a Python dictionary, but FastAPI turned it into a string of JSON. Now, those look similar. Python dictionaries and JSON strings, they have a lot in common, but there is a transformation process from one to the other because Python is not JavaScript. That is something that FastAPI by default does behind the scenes, okay? So that's something really cool because most APIs do respond with JSON. If you do need to respond with something else, like an image, you can totally do that in FastAPI. I have an API that does output images, and I can do that in FastAPI. But the default is that you return a Python dictionary, and FastAPI turns that into JSON. All right, so now what I also want to show is the auto-generated docs. So this is really cool. So if you go to just /docs, you'll get the auto-generated docs from Swagger. And what you can do is click on try it out. And there's no parameters yet, so it's pretty easy to try out. And it shows you a curl request that you'd be able to use for making that request. It shows the request URL. It shows the response body, response headers, all of this stuff. And this is all auto-generated. And it even has another way of auto-generating, which is redoc. So there's these two different documentation options. You can use whatever you want, but FastAPI does both. These are both based off of the schema that it generates. So openapi.json. So this is what FastAPI generates and then uses this to create the docs. And this is following the OpenAPI standard. So if you use any other framework besides FastAPI, it should probably also be following that OpenAPI standard. All right. So this is how we, started it up. I did see a question about breakpoint debugging. Let's see. I haven't done that with FastAPI. We could try that really quickly. Let me see. Let's see. Show all automatic. No. Let's see. I don't know whether there is a built-in one for FastAPI. I did on VisCode Day. I did a presentation where I showed debugging a Django application, and there is a built-in one for Django, but I don't know that we have one for FastAPI yet. Don might know. So that's a really good question about doing breakpoint debugging. We should totally be able to set it up using a launch.json, but I haven't done that myself yet. So I will work on that and get back to you. But it should be very doable. I'll write a blog post later. All right, so let's make this more fancy. Okay, so this is not a very exciting API. It does not have any query parameters, right? Or any sort of way of customizing this API. So if we want to add query parameters, what we can do, like let's say we want a max length parameter, right? We can say max length. And then the really important thing is that we do colon and we give it a type. So this is what I mean by using Python type annotations, is that here we can see that the type is int. And FastAPI is going to use that information to do documentation and do validation. So if I don't give it a default value, then this is required. Or I could give it a default value of 100 or just none. I'll give it a default value of none. Okay, so here it's not required, but it's just not going to be set if they don't specify it. Now we can go in here and say, okay, if max length, okay, great, thank you. So names equal just a subset of names if the length is less than equal to max length. Okay, that looks good. And then we pick from there. All right, I like that. So let's see, I've still got Unicorn running and it said reloaded. So I think that we should just have our changes reloaded. So let's go ahead and look at the docs now. And here you can see in the docs, we do now see a max length. And so we could try it out. We could put in, max length 2, execute that. And, and we got an internal server error because there is no name with a max length of 2. So we need to do some error handling. All right, so let's do some error handling. So this happens if there's nothing in this names list. So we're going to say if length of names is 0, then I'm going to raise a HP exception, and I'm going to say it's a 404. I'm going to mouse over and see status code detail. Okay, 404 detail equals no names available. Okay, so this is one way that you can raise exceptions in your FastAPI code if the user has done something like this, where you just don't have any data that you can give them. So now if we do that, let me put that in the browser. All right, now we see the response, and if we looked at the status code, we would be able to see, let's just do it in here again. We should be able to see that it is a 404. Yeah, so here the response status is a 404. Okay. Now let's try with the max length that does actually exist. So 5 there. So there we got a name. That worked. Now what happens if I type in a string for max length? So I want to show that. Now, if you type in a string, you get FastAPI's auto-generated parameter validation. And this is one of the cool things you get with these API frameworks is this parameter validation here. So it's saying that the value is not a valid integer for the max length query parameter. So that's really cool, is that just out of the gate, you get this kind of error reporting for API users. And I don't have to, actually code that myself, check to see what they passed in. Because here's the thing about Python types. Python types, these are just hints for like tools to use. They are not obeyed by the runtime. So we totally could, in theory, pass a string into this function. It's just FastAPI that's looking at it and saying like, oh, no, but your type hint said it was an int. You're trying to pass in a string. None of that funny business. So FastAPI is deciding to treat this as an error. But in Python, by default, wouldn't be treating this as an error. This is just a hint that's used by tools like FastAPI. All right, so there we've got some parameters, and we could keep adding, more parameters here. So we could have starts with, so it starts with, and there we go. And then we can go ahead and pass in a starts with equals P. There's nothing starting with P. Let's do M. Oh, you know what? We should not care about M versus lowercase m versus uppercase m. So there we go. Starts with M, Margaret. Should do like dot lower. Okay. So we could keep adding lots and lots to this. Do we have questions about what we're looking at here? Are there? Let me take a look. So Lynn is asking, oh, hi, Lynn. Yeah, if you don't like the error message that's generated, can you override it to something else? Yeah, that's a good question. So whenever I'm in doubt, I always look at the really well done FastAPI documentation, and there's a lot in it though. So the creator of this and all the contributors have written so much that I haven't actually read it all yet. So I would just go through this and see. So override request validation exceptions. So this is probably what I would look at here, is overriding the request validation. I think what you'll find, yeah, so there you go. This is exactly what you want. So instead of getting this default error, which you might not like, it's a little, maybe there's something not quite user-friendly about it. It's like a little overly structured perhaps. So you could overwrite it to just give this text version here. And that's probably what you want to do. So yeah, that would be a great thing to do if you feel like these errors will be difficult for your users to parse. Another question. Let's see. Okay, is the ports tab in here from an extension? So I'm using Codespaces. And in Codespaces, so yeah, because Codespaces, I guess, basically is an extension. So this is part of Codespaces. If you are opening this in Codespaces or locally in the dev container, so I guess I would say this is actually part of being a dev container, then you'll get this ports tab. It's a really cool tab. One thing that's very cool is that you can actually change the visibility of the port. So I could actually change this to public and I could post it in the chat. I'm not going to do that because I'm worried about maybe accidentally DDoSing Codespace. We probably wouldn't, but we don't want to mess with anything. But if you're like in a classroom setting or with your colleagues or whatever, you could change the port visibility to public and you could just ping them the the running URL of your app, which is really cool. So lots of cool stuff in the ports tab. The reason this all works is because I do have this .dev container folder, and that has a Docker file, which has the basic stuff I need for the environment, like a Python environment. And then I have devcontainer.json, which adds on a few extensions. So I'm using the Python extension. I've got Black for formatting. And down here is where I tell it what ports to forward. So it knows when it knows to look for 8000 and 7071. And it pops up those when it sees it. But you could actually run on other ports too, and you'd be able to navigate to them as well. All right, let's see. Are we going to sanitize our inputs? That's a good question. Sanitizing our inputs. So FastAPI is going to check, for, int and string. You could do even more constraints than this. Like you could really be more specific with, what's the max length of the string? What's the max size of the int? Let me show you one where I did get a lot more specific. And granted, this is actually using API Flask, but I'm sure that FastAPI has a very similar way of doing it. So here, here I have that this has to be between 0 and 30, 0 and 30, 0 and 30. This one, I got really specific of the range. So to make sure that it couldn't be greater than the max int. And then I also did some checking here to check that that two different parameters match the count of each other. So this is an API Flask. So there's a different way of doing it in FastAPI, but I'm sure we could do additional validation in FastAPI beyond just the basic of types and ints and strings, right? Because maybe the int is only supposed to be between 0 and 10. Maybe the string is only supposed to have a max length of 30. So you'd be able to declare all that as well. Cool. All right. So now let's keep going because we are going till 11 with today's. So we looked at returning errors. And yeah, and then we can test them. All right. So let's go ahead and test it. And well, very quickly, somebody wanted to generate another endpoint. Here we go. Fastest way of doing that is generate name 2. But that's what you would do, is you would just have another thing there. And there's other ways that you can organize in FastAPI. So if you want to organize across multiple files, you can do that. If you think you're going to have a lot of endpoints, then check out the FastAPI router class. That makes it easier to organize your endpoints across different files. All right, so I want to test this. I like to test everything I do because I don't trust myself. I think I write okay code, but I don't think that any code is, perfect from the beginning, especially, I am using, Copilot. I'm using online resources. Things can get out of date. It's really important to always test your code. Shout out in the chat what your, favorite way to test your code is. I am going to be using PyTest today. So to start off with, I'm going to make another requirements file. So I'm going to have, these are going to be just my dev requirements, which is different from my, production requirements. So requirements-dev. All right. Now what this does is it requires the API requirements. So I'm going to actually move those into here just so that the production stuff's all in one folder. And then we install PyTest, PyTest-cov, which is coverage information using the coverage library. We also include FastAPI bracket all, which probably seems like a strange thing. We already have FastAPI in requirements.txt, but we need bracket all because this includes the test client. If you don't have this, you are going to get an error about the test client not existing. So you do need to have this, bring in this full FastAPI package when you are doing testing. And then I'm going to make a pyproject.toml. So this is a file that's now a standard. It was declared in a PEP somewhere, and it is used to configure tools and dependencies and stuff like that. So I use it to configure my tools. So here I say that for PyTest, here's some options I like. So I wanted to check coverage of the API folder to make sure all the Python in there is covered. And here are my test paths. And yeah, and that's where it's what the modules are running from. So that means I need to make a test folder as well. So let me make a test folder and put it out here. All right, because that's where we're going to put our test. And yeah, then I'm going to do maybe test_API.py. Okay, let's see. So we need to actually go ahead and install those requirements, right? So we're going to do pip install -r requirements-dev.txt. So that goes and grabs all those things we put in that additional file. And now I should be able to write a test. So we're going to use PyTest to test the API in main.py. And yeah, so I'm going to go ahead and say def test/generate name. And let's try this. We need to actually create a test client. I'm being kind of lazy and just seeing what Copilot will write for me. And then there we go. Okay. All right. So here we go. We import the test client, and we needed to install that FastAPI bracket all to get this. Then we get the app variable from api.main. Then we create a test client, and then we can use that inside our functions. So here we have client.get generate name, assert response.status code equals 200. And this one is just checking that the name is in the possible list of names. That is maybe not my favorite way of doing it, because then I have to update that list of names every time I update the names. But let's run this and see if it works. Let's see. So PyTest. I'm going to run Python 3-m PyTest. That's why I like to run it. Okay, so that did pass, and we can see we have 79% coverage. So we are missing some lines of code. So coverage is what lines of code are covered in your file. So here it tested, this one and this one, but maybe it didn't test these lines of code, right? Because I didn't pass in a query parameter. And I did find this really cool VS Code extension that will put little gutter markers that show you which lines weren't covered. I think I didn't install it in this dev container. Let me see. Did I? No, I didn't install it in this dev container. It's very cool. So if you do love looking at the coverage of your code, you can use this coverage extension, and it will decorate. It'll decorate your code with what gets covered. But we can also just ask coverage for that information. All right. So let's see. Let's change this. So instead of checking that's in a list, I'm going to check if it's equal to some value. Now the question is, what value is it? This is a random generator. So what I'm going to do is I'm going to use a seed. This is how we can get a reliable, replicable randomness is by setting the seed. So I'm going to set the seed and then see what the name ends up being. Oh, let me run PyTest. 3 PyTest. Okay. And we see Noah is not equal to Minnie. Okay. So it would have been Noah for that seed. It doesn't like running from there. Here we go. All right. So then that test passed. Now we could try. Oh, good. And you found that coverage extension. It is really, really cool. I know I put it in one of my repos the other day, but I guess it wasn't this one. All right. So let's see. Yeah. Generate name max length. So let's see how that one works. I need to stop pressing play. So this one would be Nadia. And you see my coverage is increasing each time. So now up to 86%. Now I'm going to do starts with. All right. Let's try this out. And this one would be Margaret. Now we're at 93% coverage. So what are we missing? We're missing the error. I wonder if it's going to know. Oh, well, it suggests, yeah, I could do that too. Let's try this out. So max length 5 starts with M. And there we go. We got a 404. So that was the 404 we wanted. And that got us to 100% coverage. So we're actually going to assert that it is a 404. And try that out. All right. We are at 100% coverage. Sweet. So 100% coverage is just a starting point. That just means that, each of our lines of code were hit up at least once during our tests, but it doesn't mean that we've tested every possible way of hitting up this API, right? There's so many things that people can throw at this API, and that can lead to all kinds of issues inside. When you are running an API, like my partner will he gets paged when somebody misuses their internal API and throws something at it that they weren't expecting. So how do we really gain a lot of confidence in our API? So this is where I like to use something called property-based testing. The idea of property-based testing is that you can tell a framework here, these is the type of parameters that this function can take. Now throw everything at that, at that function and test all the edge cases, right? So test really big numbers, test negative numbers, test 0, test all those things and see if there's something that I missed, see if it breaks. So I'm going to show you how to do property-based testing with FastAPI. So how do you do property-based testing in Python? The most popular library is called Hypothesis, and that's for general property-based testing in any Python project. But there is one specific for testing things that use an OpenAPI spec, and it's called Schema Thesis. It's built on top of Hypothesis, and it specifically looks at the OpenAPI spec that gets generated, and then based on that spec, it throws stuff at the API. So I thought this is really cool. So let's go back into requirements-dev, add schema thesis, and go ahead and do an install again. Where's my install command? Okay, I'll just manually write it. Oh gosh. Pip install -r requirements -dev.txt. Okay. All right, so that's bringing in a bunch. Okay. And now I'm going to make a new file. I'm going to call it property-based.py. I'm going to put it in my test folder. All right. And I'll just bring in this code and explain it. So we import the schema thesis library. We import our app from api.main. And we tell schema thesis that we are giving it an asynchronous application, so from ASCII, and tell it that it can get the OpenAI spec at this route in that app. And then we pass it the app. So it's going to basically run the app and then hit up that route to get that spec. And then we just tell it, we just use this function here, test API, and put this decorator and tell it to call it. And then it's going to just run a bunch of code. So let's see what happens. Let's see. So I'm going to do pytest-k test API. And that should run just this one. Oh, actually, sorry. I need to explicitly call this function. So pytest, I'm going to do pytest test/property-base.py. There we go. So wait, wait. Did that run it? No, I'm not sure. Wait, is my code perfect right now? Is it? It might be. We should like take out somehow break the code. Yeah, it's not giving me any errors. Let me think how I could break this. Right. Well, if I didn't do this, then that would definitely break it. So let's get rid of this error handling here. And then we'll find out if this is working. Yeah, okay, so then I clearly am not calling this correctly. So let's see, collecting 4 items, 0 selected. Okay, so not -k, we're just gonna do explicitly giving it the path. All right, there we go. And this will take a while. So that's why I name them differently, because I actually don't want the property-based test to run all the time. I want to be really explicit when I run that test. So that's why it took me more effort to run them, because it does take a while, because it's throwing like every possible combination of parameter types at your function. And so what you can see is that it did run into that issue where it got an index error, and we could look and figure out like, okay, well, it got an index error. That means there's a bug in my code. Why it was getting an index error? All right, let me go ahead and add in some error handling, and then let's see how it goes. All right, so it did a lot better this time. Now the only issue is that it said it received a response with a status code which is not defined in the schema 404. It says the only declared status codes are 200 and 422. So this is really interesting. I didn't know that you had to declare a 404 specifically in the schema. And if you look at the openapi.json, you will see that, let me see, do we still have Unicorn running? Yeah, should still be running. You will see that it has 422 and it has 200, but it doesn't have 404 defined. So you actually do, if you want to have that in the schema, you can you put it here inside this get here. Try and remember how we how we do that, because I've only done this once so far. Let's see, open additional responses in open API responses equals 404. Okay, yep, there's we go. Okay, so we can just do responses equals 404, and it's actually, I think, fine with an empty dict here. Okay, so we're telling it that 404 is an okay response. There we go. All right, so we've now passed schema thesis as well. So we could go ahead and like add a test that 404 was in our schema or something like that. But this is something for you to think about, is property-based testing, to add another level of confidence to your testing, because I want you all to write, really robust code and to not have to get paged. That's always the goal. Don't get paged. Oh, and I see, okay, so Luciana's in the chat talking about test discovery to be more robust. Okay, we can check to see if test discovery probably will work for this, because I'm using PyTest directory containing the tests. Let's see. I'm just going to refresh here. So there's VS Code has this testing tab. I think I found it. Yeah. So if you're using PyTest or unit test, it can auto discover your test. Let me try running these, and yeah, all green. So there you can see that testing tab. So yeah, it does. This one works in testing tab. Notice it doesn't have the property-based test here. That's on purpose. I specifically did not use the standard naming scheme for my property-based tests because I don't want it to get auto-discovered because these tests are so slow. So typically what I do is like I put them on like a different CI/CD hook so that they're not run all the time, but they are run on some sort of basis. And I use a different naming scheme so that they are separate. Thank you, Luciana, for that reminder to use the testing tab. The testing tab is very cool. Okay. All right. So now we need to be able to actually deploy these apps. All right. And we've got 25 minutes left, so we should be able to do this. So let's talk about productionizing FastAPI apps, getting them ready for production. So we've been using Unicorn to run the local server so far. The problem with Uvicorn, sorry, I say unicorn because I have a 3-year-old daughter and we talk about unicorns constantly. Okay, but Uvicorn. Uvicorn can only run one process at a time. But on a production server, we want to be able to take advantage of multiple cores, multiple CPUs. So what we're going to use instead is GUnicorn, which is a production level server that can run multiple worker processes and multiple threads. And luckily, there is a way to use it with asynchronous frameworks like FastAPI. So we go ahead and add it to our requirements.txt and also give it a version. I should have given a version for the other ones as a best practice. And then we can use GUnicorn command to run FastAPI app, but we have to use the Uvicorn worker. So we still do need Uvicorn because GUnicorn doesn't inherently know how to run an asynchronous app like FastAPI. So it uses the Uvicorn worker in order to run it. So here we can see, here's the app. This one runs with 4 workers. Here's the worker class from Uvicorn, and then it binds to 8,000. Let's try this out. Wherever. No module, I need to install. Always got to install. All right, and now let's see. Oh, it can't connect because we are still running our Uvicorn. So let's quit that Uvicorn and run again. And now notice that it says booting worker, and you see that it's booted multiple workers because it's saying GUnicorn can run multiple worker processes. And let's make sure it's still working. Go to /docs, see all our parameters. All right, it's looking good. But I want to go a step further with GUnicorn and use a configuration file for it. This is another best practice to do if you're using GUnicorn because you can get a lot fancier with your configuration. So I'm going to go ahead and add a gunicorn.conf.py. All right, so what is this doing here? This is actually going to dynamically decide on the number of workers based off the number of CPU cores in this environment. So this is what's recommended by the GUnicorn docs, is to base worker count on your CPUs available. And this makes a lot of sense, right? If you're on something that has, 12 CPU cores, then you can afford to start up a lot more workers. But if you're on a tiny machine, then you wouldn't want to do that. You'd end up overwhelming the machine. So this is the formula they recommend, is 2 times the CPU count plus 1. So that's what we're using here. And GUnicorn will automatically find this gunicorn.conf.py if it's located in the same folders where you're running it. In this case, let's test it because I'm actually moving it. I put it in the API folder. So is it going to find it in the API folder? Let me just do a -C. Oh, main :app. Oh, yeah. So we'll just go inside the API folder. Yeah, that's how we'll do it. CD API. We'll run it from there. All right. Open it up and go to /docs. Looking good. All right, we are ready to host it on Azure. So if you want to follow, I guess I'm curious if anyone has managed to follow along. It looks like people are attempting to follow along because I see some debugging happening in the chat. So that's really cool. And thank you to everyone who's helping out with the questions there. If you have followed everything I've done, including GUnicorn, then you could, in theory, deploy your project the way it is. But you could also go to this branch here, which is the same repo, but ready to deploy. So it basically has all the changes we've been talking about. So if you do want to try deploying it, but you didn't follow along up to here, then this is, later on in the process, you can grab this URL here. Let me see if I can copy and paste that for you. Oh yeah, we got people following. Cool. All right. All right, so things to consider in terms of deploying this app to Azure. And this is what you need to think about whenever you think about deploying, hosting something somewhere is, how much traffic do you expect, right? Is this just a demo app, a hobbyist app, or is this, an action production app you're doing? Is it internal only? Is it public facing? Is it, the next Twitter? I guess we're going to have a lot of next Twitters. How variable will the traffic be, right? Like, do you expect to, potentially have a huge number of people at one point, right? At Google, my 20% project was the NORAD Santa tracker, which was my favorite thing ever. And I spent many Christmases in the Google office taking care of it, responding to letters from Santa because he was very busy. So our traffic was very variable, right? We had no traffic until Christmas Eve, and then boom. And then particularly every 4 minutes, we had a huge amount of traffic because that's when Santa magically flew to the next location. So think about your traffic variability. Think about whether you need to scale to zero, right? Like, is it potential that your app will have zero traffic? And in that case, you wouldn't want to pay you wouldn't really want to pay much of anything at all if you have zero traffic, right? And generally, what is your budget? What are you willing to pay? For all the stuff today, I attempt to use the cheapest tier possible. And in this case, the free tier we're going to be using for this particular one. But some of the, these things do cost money. We're actually using Microsoft resources. So we do need to look at the pricing tier whenever we consider what we're going to use. And since it's an API, is this a public facing API? Is it going to have, consumers, public consumers? You're going to need subscription keys, all of that stuff, in which case you'll have a lot more considerations. So there's a lot of ways to host on Azure. This is just 4 of the options, but they are the 4 that I consider the most often, and they're good ones to pick from, right? So we have classic platform as a service on the right here, and there's the classic serverless option, Azure Functions. So that's similar to Google Functions, AWS Lambda. So that's if you have something like really quick, fast startup that just needs to process something and go back down. Then we have Azure App Service, and that provides a lot of management for you and tries to really help out with the whole process of running a web app. Then we have stuff more on the container side. So there's Azure Kubernetes service. If you want to go all out and you're ready to be a Kubernetes admin, I'm not. So I've actually never used that myself. What I tend to use instead is Azure Container Apps. And that's what we're going to use in the last session of today. So, come back or keep tuned if you want to see Azure Container Apps. For today's session, for this session, we're going to use Azure App Service. It's a really nice fit for FastAPI, and it has a free tier. That's important too. There are many ways to deploy to Azure App Service. You can use the Viz Code extension. You can use the Azure portal, and then you could hook up a little GitHub CI/CD action. You could use the Azure CLI, or you could use the Azure Developer CLI. I'm going to try and show all these possible ways of deploying at some point today during one of our sessions, but not all at once. And so that you can just look at the different ways of deploying and decide which one is going to work for you, for particular uses. So for this one, we are going to deploy using Viz Code. In order to do that, we need the Azure Tools extension. So luckily, I already have that because I installed it here. But if you didn't have that, you could go to extensions and then search for Azure. And by the way, you shouldn't think that any of my pronunciation of anything is correct. But I do think that Viz Code is the best way to pronounce Viz Code. I am wrong, but I still think it. So this is the one you want, this extension. This is actually kind of an extension pack that brings in a bunch of other extensions. But the easiest thing is just to install this extension pack, and it'll bring in everything you might possibly need. All right, so we have that extension. And then what we're going to do is find the Azure. Wait, where's my Azure tab? The A over here. We should have an Azure tab pop up. Well, let me also try my pre-baked one because it looks like maybe my extension didn't load. So let's go to this one, not this, code, create code space, this one, okay, Let's see what questions we have. Oh yeah, there's a question about the Azure function, the new Azure function Python dev style v2, and whether it uses FastAPI. It doesn't use FastAPI, but it is using a really similar style. It's using the decorator style, and that's just also just something we see across most web frameworks. So where the Flask framework also uses the decorator style. It's just it's a really popular way of decorating routes, and they moved to that for Azure Functions v2 to make it really easy to have multiple functions in a single file, because there was a lot of feedback that that was difficult to do. So it is not using FastAPI itself, but you should be able to, I haven't tried it yet, but in theory, you should be able to use FastAPI with it, and hopefully they would work together. But it is just a really similar style. So that was the goal of Azure Functions v2, was to be more Pythonic, and decorators are very Pythonic. So Rachel asked, does it matter if we create a code space on that repo directly, or should we fork it first? Yeah, good question. Generally with code spaces, should you create the code space or fork it first? What you can do is you can always create the code space, and then if you do end up making changes that you want to store, forever, ever. Then what happens is when you start running Git commands, Codespace actually detects that and then offers to make a fork for you. And it usually works. Sometimes I've gotten myself into weird situations just because it's Git, and it's easy to get into weird situations with Git. So if you know for sure that you want to keep your changes and make some changes to it, then you could make a fork first and then a Codespace. But in theory, you should be able to make a Codespace and then decide at some point, like, oh, I've got some changes I want to commit to my own fork, and Codespace in the terminal will say like, oh, hey, we'll make a fork for you. Let's see how we're doing here. We can also try, so if you ever do have, an issue with a Codespace, you can also try to rebuild the container, and that will keep the, it'll keep all your code changes. It just tries to rebuild all the parts of the container. So, in this case, if I thought that the extension didn't load properly, I'm giving it another chance to load it. All right, let's see here. I'm going to check. We'll go ahead and look and see what's installing. Azure. So we see it is installing here. So we see lots of installing happening. So we can wait for that. We have a question. What is the purpose of FastAPI deploying to AZ Func app? Can't I just write my function, AZ function deploy without FastAPI? Definitely. Yeah. So if you're deploying to Azure Functions, you actually might want to consider only using Azure Functions and not using FastAPI, just for a performance perspective. We haven't done benchmarks, but we think it's possible that, there's probably performance hit to FastAPI in any framework, because they are a framework and frameworks add code on top. So if you're really going for speed and you're deploying to Azure Functions specifically, because Azure Functions is, serverless, it's meant to be very fast startup. then you may want to just not use any framework at all. So I do have examples for Azure functions. Let's see, functions. And here's one that does not use any. This one does not use any framework at all. So yeah, we're not going to show anything on Azure functions today, but that is an option if you're going for a serverless functions approach. And yeah, I think it's definitely worth considering not using any framework if you're really going for speed, right? So have nothing in the way of your code and Azure functions. Okay, let's see how we are doing with trying to get some Azure stuff happening here. Oh, sign in. Can I enable? I want to enable all of these. Enable. Let's see. Give me everything. No, I just want enable. I want the A. I want that A. Oh, man. All right. We are going to go locally and see what we can do. Let's see. So clone Git repository. And let's see. Can I clone from a branch? We'll find out soon. Okay, I can't. Let's see. And yes. Yeah, my profiles get a little confused because I have multiple viz codes locally, and I've got setting sync on, and I probably did something yesterday that messed with the Azure thing. So I'm going to reopen in. Actually, I'll just keep it like this. Okay. And let's go ahead and get the terminal up. Okay, so now I'm in my local viz code. And let me see. I want to check out git fetch. And let's see, git checkout. What's the branch? Deploy to Azure. Okay, all right. So this has the gunicorn.conf. Okay, great. All right, let's see how we can do this. So we're going to go here, and this is the Azure extension. So you can see this A over here. And what I can do is say, create app service web app. And FastAPI May 2nd is going to be my awesome name. Select my runtime stack. I'm going to go for 3.11. It's the fastest. I'm going to use free F1, so I don't have to worry about cost for this one. And now you can see that it is creating the web app. So this is the A that I kept looking for. I said, oh, where's my A? Where's my A? So this is the Azure pack here. And it's probably something with my setting sync, which meant it didn't show up. Oh, can't see my screen. Oh, okay. It's only sharing. All right. Thank you. Let me try presenting again. And let's see, entire screen. Aha, here we go. All right, and then can the host, thank you. All right, here we go, thank you. So let's do it again. We'll make another one. So I went to create app service web app, and then FastAPI May 2nd, 10:53. And runtime stack 3.11, free F1. And now it's creating another web app. I feel a little bit like a hoarder now. The selected plan currently has 3 apps. Deploying more than 3 apps may degrade the performance. Okay, all right. That's because these are all loading on it's the same app service plan. So I could make a separate app service plan. So you can make an app service and an app service plan, and a particular app service plan can have multiple app services associated with it. So that's creating, and the previous one already created. So I'm actually just gonna find that in the portal. Let's go to my portal and find it. And here we go. No, that's something else I deployed. Sorry. Test May, was that? Let's see. So test May. And, because it's not, which resource group did it end up in? That's a great question. All right. Oh, now it created this new one. Okay. All right. Now, if we visited this right now, what we would see is just the default handler for Azure App Service websites. So I want to get that to load. And then also figure out what resource group it went in. So FastAPI May is here. Okay. All right, so I've got that open. Web app loading. All right, so that's, oh wait, let me reload that again. But basically, there is nothing deployed. There's no code deployed yet. We still need to actually deploy our code. So that's the next step that that we need to do. So we can go and right click and say deploy to web app. And I'm going to select the folder to deploy. So I'm going to tell it specifically to deploy the API folder because that's all the production stuff. It shouldn't need the stuff outside that folder. And that's a nice way to structure something. Are you sure you want to deploy? Yep. And always deploy. Yep. This will update my settings. All right. And we'll check the output window. So you can see what's going on here is you can see that it's actually zipping up my code and sending that code to the Azure server. So we can watch that happening. Let's see. Let me also go here. So not while that's happening. We need to be patient and wait. This is when we meditate. Sorry, I can't meditate on things. Let's see what questions. So what do we see? It is, this is doing the build. So when you deploy to app service, Microsoft has a tool called Oryx, and Oryx does actually try, it builds an image, it builds actually a container, a Docker container for your app. And so it'll actually like look for requirements.txt. So it's going to find that requirements.txt and install all those requirements and put those in the image. It also does try to auto start an app if it's Django or Flask, but it doesn't understand FastAPI yet. That's something that we're working on, but we will tell it how to start a FastAPI app since it doesn't have it built in. But if it is Flask or Django, it will look for like the manage.py or, the Flask app and try to auto start that when it's building. And this is all handled by Microsoft Oryx. So if you ever need your friendly neighborhood issue tracker, there's Microsoft Oryx. So this is a thing that is building the repos when you deploy to app service. And if you go here, you can see that there is an open issue about FastAPI. And hopefully we'll make it even better supported. All right, so we can see that it is deployment completed. Okay, now if we browse the website, we just see this default website, and that's because it doesn't understand FastAPI inherently. We need to tell it how to start that app. So what we're going to do is remember that startup command that we used with GUnicorn? We need to tell app service about that. So we go to configuration. Let's see if we can make this happen in 2 minutes. Get pumped. So we go to configuration and we wait for that to load. I see a question about tying a custom domain name. You can always tie custom domain names to to whatever you use, whether it's container apps or app service. So you can see that listed here in the custom domains. So it's kind of how you do it in most places where you have to do like a CNAME linking and stuff like that. I think you can't do custom domains on the free tier for app service. but I would need to double check that. So if you are interested in a custom domain, you should check that, whether that's a limitation of the tier, especially if you're using a free tier. Okay, so in the configuration, I'm going to go to General Settings and go to Startup Command and put Python 3-m gunicorn main:\app. And now it's going to know how to start it up. And it says this is going to restart my application. Beautiful. That is what I want. So it is now updating the settings, and hopefully restarting the application. I'm going to open up the log stream over here. Oh, no, I'm going to keep this open. You should save. Did you save? I think you saved. Ugh. Okay, it's still updating the web app settings. I'll open log stream in another window. So if you ever need a quick way to see your logs, you can look at the log stream for app service. And then you can watch it load. And let's see what the final slides are as it's doing that. So we'll let that load and quickly go through the final slides since it is 11 o'clock. If you are looking for more examples with FastAPI, we have tons more examples. There is FastAPI plus Azure API management. That is fantastic if you are doing an external public-facing API, because API management gives you subscription keys and rate limiting and IP blocking and lots of really cool features. There's FastAPI plus a CDN. That can also be a really nice fit for an API, because the CDN can cache the responses on the edge and make them much faster, and mean you pay less for your API because it's not being hit up as much. Well, I have another example which uses FastAPI plus scikit-learn. So if any of you are coming from a data science background and you want to turn your scikit-learn model into an API, that's something that's actually pretty easy to do. And there you go. Let's take a look and see how we're doing here. And I think it updated, and now we're going to reload. And oh, yes, we did it. Here it is. It is running. It is live. I will paste it here and see if you DDoS me. But there we go. Okay. Thank you, everyone. It is now 11:01. So we are going to take a break before the next session so that I can drink some water. And thank you to everyone in the chat for answering lots of questions. Remember, you can refer to these APIs for anything that we discussed, and hope to see you in the next session. All right, welcome back. I think we are live now. Live again. Can everyone say hi in the chat so we know that we are back? And I will share these slides in the chat as well. And we're back. Hello, hello, hello. All right, very cool. So hopefully you all had a little break there, drink some water, got a snack, and now we are going to be talking about databases and Django. So we're going to be covering databases generally for anyone who hasn't interacted with databases before. If you're new to databases, shout out in the chat, or if you don't want to, but hey, everyone's new to everything at some point. So just briefly on what databases are, how we interact with databases in Python and in VS Code, particularly using a really cool extension, how to host a database on Azure, then getting into Django and hosting Django on Azure. Brief introduction to databases. Why do we need databases? So basically, we're making an app. If we need some data that can be shared across multiple users of that app, we're going to need a database to store that data. So, a lot of times we use a data for, social media, right? Like Twitter, all our tweets are stored in a database. All our toots are in a database somewhere. Facebook profiles, all those in a database. Even something like high scores for a game. If it's data that needs to be centrally accessed by all users of the app across the world, then we need to store it in a database. And a database is just a program that is very good at storing data and retrieving that data back out. If any of you are data scientists, you probably have also used databases in order to do analysis, and that's another use for databases. There are various types of databases, and they get loosely categorized into two types. One, which is relational databases, so MySQL, SQLite, PostgreSQL, and that's what we're going to be looking at today. There's also document databases or non-relational databases, NoSQL databases, whatever you want to call them. So MongoDB, Firebase, CouchDB, classic Cosmos DB. That's another very valid type of database. But we are going to be looking at relational today because that's what a lot of Python developers use, and that's what Django generally uses, is a relational database backend. But please shout out in the chat with what your database experience is. What is your favorite database? What do you use it with? What do you recommend? What are your faves? What are your unfaves? Yeah, I saw somebody mention that Excel is the best database. You don't know how many apps I've run off of spreadsheets. So remember in the first session, I mentioned that at Google, my 20% project was the Santa tracker. That was running off of a Google spreadsheet. And it was actually a public Google spreadsheet. And at some point, someone found it and published all of Santa's itinerary. So that was a bit embarrassing, but no big deal. So yeah, so relational database structure. A database contains tables. Each table has columns and rows, very similar to an Excel spreadsheet. Here we can have an example table called restaurants. We have the first column ID. Generally, every table is going to have an ID column so that we can uniquely identify each row. Because a name is not really a unique identifier. You could have multiple restaurants with the same name. So you need a unique ID of some kind, and it needs to really be unique. And oftentimes we let the database take care of that for us. Then we could have a name, an address. Typically columns have types, like there's strings or integers or whatnot. And in a relational database, the cool thing is that you can relate tables to each other. So if we're making a restaurant review app, we could have the restaurants, and then we could have a reviews table, and the reviews table would just have a column that referenced a restaurant ID. And so you would know that, oh, this review here is referring to restaurant ID 3. And this review here also referring to restaurant ID 3. And that's the whole idea of relational databases. And this is what we call a foreign key. This thing here is a foreign key for the restaurants. We are going to be looking at PostgreSQL today. It is I guess I'm supposed to pronounce it Postgres. I'm still learning how to pronounce it. But it is a popular open source relational DB. It has a very strong community and very strong extension ecosystem. It has the PostGIS extension for geographic data, which is really powerful. And I think it's the most powerful of all of the geospatial extensions for SQL databases. So if you're dealing with geodata, definitely want Postgres, but it has also lots of other extensions as well. And they're all coming from the community. So Postgres is free and can be installed on your computer. You can see my computer has a little elephant up here. That's the Postgres elephant. His name or their name, I don't know, but the name is Slonic or Slonic. I'm not sure how to pronounce, but it does have a name. So you can install it locally. It's also available on Azure with a couple different services. And we just had a conference all about it called CitusCon. And I was at that conference as well. It was a virtual conference. So all the talks are on YouTube. And you can just look at the hashtag CitusCon. If you are a Postgres developer or getting into Postgres, there's some really good talks there. I learned quite a bit from looking at those talks because I'm actually pretty new to Postgres. I traditionally have used MySQL quite a lot because back in the day, I was a LAMP developer, Linux, Apache, MySQL, PHP. So that's what I had the most experience with. And also it's what we used at Coursera. And then at Google, I used, Big Table. So I'm new to Postgres, but there's lots of cool ways to learn about it. First, let's look at how to interact with Postgres inside VS Code. And here is the project that you can follow along with. So go ahead and share this in the chat for anyone following along. So I've set this up to make it easy to play around with Postgres. So let's see, I've got it open here. Okay, so this is actually open in a code space, but the cool thing is it's possible to run Postgres inside a code space. So I've set up this dev container to run Postgres. You can see in the ports, Postgres is running on port 5432. And so I can interact with Postgres running on that port. The reason that's working is because in my dev container, this time I'm using this Docker Compose file. And in the Docker Compose file, I'm bringing in this Postgres image and, configuring it with some, this is just all local user admin and password. And then in my dev container.json, I am setting up this 5432 port so that it knows about this port. So I just want to point out that it is possible to create a Postgres server inside of a dev container, inside of Codespace. I love this because I hate local Postgres. I'm always messing it up. I'm always forgetting how to set up a restaurant, with that little local app. And it's always breaking for me. And then I have to remember not to, create a database with the same name as another app I'm working on. So I love to have Postgres inside my development environment, inside the dev container. Okay, so it is running, and I've got this SQL Tools extension here. This is a third-party extension that I've installed, and I've also installed the Postgres driver for it. So these are the extensions I recommend if you're using Postgres inside of VS Code or inside of Codespaces. And then I also set up some connections in the settings. So here we have the local connections, and this uses all the details that were used in the Docker Compose. So these should be how we can log on to this local database. And I also have a connection for an Azure database, and we'll try that out later. The big difference there is that it's using SSL because this is a production database over, a secure connection. Okay. So we should be able to connect to this local database. Let's click on this. And I'm also going to reload this Codespace, see if I can get my icons back, actually. Let me check the chat, see how we're doing here. Yeah, so I see some mentions about NoSQL. Got some representation of NoSQL in the chat. We are going to be trying some SQL alchemy today, actually. So we are going to do a little bit of that. All right, great. So I got my icons back. So I'm going to click on local database and expand that. And you can see the post, you see it says Postgres. This is the name of the database that's inside the Postgres server. And then I can expand schemas, public, tables. And what we see is that there are no tables yet. Well, that makes sense. When you first create a database in a Postgres server or any kind of SQL server, you're not going to have any tables to start off with. So we need to figure out, how do we make some tables? Now we could actually run raw SQL here. So let's see, create table. This is where, I've taught, it's kind of embarrassing because I taught, SQL on Khan Academy. I should be able to do this. If not exists, there we go. Oh, good. Copilot. Let's see, is that going to work? I don't know if it's going to be text or varchar though for Postgres. Let's try this out. Run on active connection. Did it work? Let's see. Oh, it worked. Oh, that's pretty cool. I didn't think that was going to work. It's valid SQL. Amazing. So I did just run SQL using the SQL Tools extension. So yeah, you can actually just use actual raw SQL in order to interact with this locally running database here. And you can do this all with SQL Tools, and you get a query history and all that stuff. And we can look and see if there's any rows in that table. But we want to see how to interact from Python. All right, so this is how we set everything up in the dev container. So you can look back at this to remember. Now we want to interact from Python. So how do we interact from Python? So first, let's look at our requirements.txt. So here, going back to our files, I've got this psychopg2. What this is, it's a package that knows how to interact with Postgres. It is pretty much the package to use if you're using Postgres from Python. And it is possible to just use this package directly. So I actually have that here. here's some code that uses the package to connect the environment. So first it loads environment files from this .m file. So we need to make this exist. So I'm going to make a .m file and just copy into here. So this is just my local environment variables for the local database, but I like to store it in a .m file. So we load it in from .m, and then we get the value of those environment variables. Then we create a connection with psychopg, and then we have this SQL statement here. So insert into restaurants, ID name, okay. And we can try running this. See if it's going to work. Let's see. Okay, so what we haven't actually, because we put a lot of stuff in here, so it looks like these are all not null. So we need name, address, phone, website, image description in order to make it happy. And but you know what? I'm not going to go through all that effort, because what we see here is that basically it worked, right? It did try to execute this insert statement to the database, and it just failed on the fact that we didn't specify enough of the values. So it is possible to access, and use SQL to access the database, but generally we do not want to do this, because this puts us subject to SQL injection. So this is the obligatory XKCD reference about little Bobby tables. And I did not name any of my daughters little Bobby tables for various reasons. Or little Bobby drop table students. So basically the point is, you never want to be writing raw SQL, especially if you're bringing in, if you're writing a web app where you're getting user input, because the user can input something that then gets mixed in with your raw SQL statement and then gets executed against your database and does something horrible like dropping all the tables. So we don't want to do that. Let's move on. What we want to use instead is an object relational mapper, an ORM. That is a higher level abstraction for interacting with a database using object-oriented programming. So using classes to represent tables, and each row is a Python object. And these ORMs will provide safe methods for querying and modifying data. The most popular ORM for Python is probably SQL Alchemy. And it can be used with any framework. So you could use it from Flask. You could use it from FastAPI. You could use it from Django, but Django has its own ORM, which we'll see. So we won't use it from Django. But let's go and try out SQL Alchemy. All right. So yeah, looking at our requirements.txt again, you see I brought in SQL Alchemy and also brought in some stuff I don't need. But there's my SQL Alchemy. Going back here, I've got a bunch of imports. And first I have to, this is using SQL Alchemy 2.0. So SQL Alchemy very recently released a 2.0 version. It has a bit of a different interface. So if this looks a little different, it's because this is using the updated interface. So first we have to create this base class, which will be the subclass, the superclass for all of our models. And then here I have a restaurant class, and currently has an ID and a name. We could add some more stuff to it. We'll just add whatever Copilot wants to add. Latitude, yeah, sure. Okay. All right, very good. So there's our restaurant class. And then we connect to it. And we're going to connect using the PostgreSQL string, because this is a Postgres database. So we create an engine using this database URI here. And then we tell it to create all the tables in the database. Now, currently, there's already a restaurants table. So I'm just going to rename this table name to restaurants 2, so that we can create that. And then we could insert data or issue queries. But let's just try this and see if we can create that restaurants 2. Okay. And you can see here it echoed out the SQL that it did. And it wrote very similar SQL to what I wrote when I was using SQL tools, but this is much safer SQL. Now we can go back to SQL tools and take a look, and we see restaurants 2, and we can see all the columns there. Okay, cool. So now we could go ahead and insert some data. So I'll just say insert restaurant, and I'll just let it bring up some stuff here. Very good. And then we add that to the session, and then we commit, which actually makes the changes in the database. And then we could, select restaurants named the noodle bar. All right. And then we can do a query. And there we go. Actually, I guess that's an okay way of doing a query. There's a more updated way of doing the query. So we're going to say query equals select. And there we go. That is more updated. But we do need to import that up here. Is it here? Sorry. And then we need to get the results. Okay. All right, let's try this out. Let's see, this was imported from the wrong place. That's why I shouldn't just make up. Let's try this. There we go. All right, so this worked. We can actually see that it ran the insert, then it ran a select, looking for the name, and it did it using the sanitize SQL query, and then we got back that result. So this is how we could use SQL Alchemy. I did see, in the chat, I saw someone mention they're getting a key error. If you are running this code and getting a key error, that's because you haven't made the .m file. So the .m file, you do need to make that in the space. The reason you need to make it is because I never check .m into source control, because people might accidentally put production credentials here, and I don't want anyone to accidentally put production credentials into source control. I do recommend enabling GitHub secret scanning on all your repos to catch that. It's a really nice feature. But I also recommend always having a .m file that is not checked into source control. So you can see it in the .gitignore that it's not checked in. And that's where all your details go. But it's super easy to make it for the local environment. Just copy and paste .m.dev container into .env. So you can just take it from here and put it into here. And then you shouldn't get any key errors with the environment. Okay, cool. So there we have it. That's how you could, interact with the database inside VS Code. Yeah, it does say, it says rollback after the select. It did do the commit here. But I wonder why it does say that. I need to look into that. All right, now what I want to do is actually create a Postgres server on Azure and connect that inside my code space. So let's see how we're going to do that. How do we host Postgres on Azure? Now, we could actually put it on a VM, but there's a bunch of managed services for Postgres where the team have put a lot of effort into figuring out how to really nicely run a Postgres server. So I recommend using one of these managed services. The first offering they had was called Single Server. That's kind of, I think, basically deprecated at this point. So it's not suggested for new apps. So we're pretty much going to ignore it. The next thing they came out with this Postgres Flexible Server. And that is a fully managed service with vertical scaling. So you can increase the hardware, the CPUs that's running your database. And that's what we're going to use today, because that's what I use the most often. There's also Azure Cosmos AD for Postgres. That is running Postgres with the Citus extension, which is designed for distributed databases for scaling horizontally, meaning that it can put it across multiple machines. So if you're really going for a large amount of scale, then you definitely want to consider Cosmos DB for Postgres. But if you're in the middle, I like to use the Postgres Flexible Server because that's at the level I need. But you can learn more in these blog posts here. So how we can make Postgres servers lots of different ways. We're going to try out the portal today to see what it's like to create something in the Azure portal. And I think it's nice actually to use the portal the first time you make a Postgres server because it does show you a lot of the options in one place. And it also shows you a pricing calculator, which is pretty interesting. So that's aka.ms/portal-postgres, or just go to the portal and look for Postgres Flexible Server. All right, so here I am in the portal, and I need to select a resource group. So I'll just grab one. You could also create a new one. A resource group is just a folder for resources. So a lot of times I have a single resource group per app. But if I'm making a demo, I can just stick it wherever. But you can just think of it as basically a folder. Now I need details for my server. So we're going to call it test May 2nd, 11:33. This way I know, when I'm looking back, like, oh, okay, I made that on May 2nd. I should delete it now. Then I pick a region. East US should be a good region. Hopefully there's availability there. Sometimes you will get errors because there's not availability in a region, and then you have to pick a different region. But I've had good success with East US recently. Postgres version, the most recent is 14, or the most recent supported one here is 14. So we're going to use that. And then workload type. This is where it's really interesting. This is, we're choosing the tier. If you look at the current pricing calculator, you see it's estimating 144 per month because this is on production small. I'm going to go to development where it estimates 16 per month. This is on an hourly basis. So this does actually cost a little bit of money. So if you're following it along, you want to make sure that you have a couple options. One, if you recently created your Azure account, you do actually get a certain amount of free Postgres for your first year. So if you go to free Azure, let me see, we can take a look at what it is for Postgres. So you see, you get 750 hours of flexible server. So if you are on your first year of having an Azure account, then hopefully it is actually free for you. If you aren't, if you've had an Azure account for a while and you're past the free services, then keep in mind that this burstable tier can cost, depending on where you're getting it from. For me, it'd be up to like $16 a month. So you do want to take it down as soon as you're done playing with it. Okay, and then I can leave all that the same. I'm going to go down here to admin username, and I'll just give it an admin username. So it's going to be Pamela admin. I should remember that. And a password. And I'm actually going to use my password manager for this so that it is stored there. All right. And then I'm going to click review and create. And it gives me a little recap of what I'm making here. So we want to make sure it's burstable B1MS. That's the cheapest tier. And yeah, that looks good. And there's a question that can you install custom extensions? So right now, the managed Postgres has a list of vetted extensions you can install that includes the really popular ones like PostGIS. I don't know about installing custom extensions and if there's a roadmap for that. Have to ask the Postgres team. I'm going to click create server without firewall rules because we're going to add it after the fact. I see a good discussion in the chat about horizontal scaling versus vertical scaling. Thank you, Aaron. Aaron is our resident, well, I think of him as our resident Postgres expert. So thank you, Aaron. So it is currently creating the Postgres server. I do find that usually takes a few minutes to carve out that server. So we can wait for that. Let me see what else we're chatting about. Yeah. Yeah, I would love if we had a free tier of Postgres. I mean, we kind of do if you are on your first year. I'm actually still on my first year of having an Azure account. So I am using I'm still using the free amount for on my personal account for one of my personal websites. But it would be great if we could have more tiers available. All right, so let's see. So while that's going, can't do that yet. Let's go back to our playground and see what we might need to configure in order to connect to this production database. So our .env, we're going to have to update the .env, right? So the DB host is going to have to change. So we'll have to look and see what it is when it deploys. The DB user, I remember, was Pamela admin. DB pass, I am not going to type my password right now. because you could see it. So I have another approach to this. And then database name, I just kept as the default Postgres. So by default, every Postgres server will have a database named Postgres. So I'm just using that one. Let me see. Okay, still deploying there. So my approach to the password is that I created a secret for this code space. So that's something you can do if you're using Codespaces a lot, is you can actually create secrets for them. And you can say like, oh, that, such and such secret can be shared with, this list of repositories, Codespace repositories. So I have a secret that's already in the environment, and I'm pretty sure this is the name for it. And it should be what I entered there, hopefully, if I did this right. So I was stuck trying to figure out like, how can I connect without showing them my password? And I think this is going to work here. But we're still waiting for our host and for this deployment to keep going. Yeah, I see a mention of Azure Key Vaults in the chat. Azure Key Vault is generally where I do keep my username and passwords, and that's what I use typically when I deploy Django applications, is I use Azure Key Vault to automatically store the passwords there. And I often even generate an admin name and even store it there. Because if you're trying to be really, secure with your database, then you could actually randomly generate an admin username and randomly generate a password. So if you generate both of those, that's even harder for someone to hack into the database, right? Because if they're, there's a chance that they could succeed with, a password attack, but having to do both a username and password attack, so that's hard. So I actually like to store both of those, admin username and password, in a key vault. All right, and we are still deploying. Oh, I could just use one of my pre-made ones. Silly Pamela. Okay, go back here. So let's just go ahead and find one that I made earlier. So that's the one that's currently deploying, but I don't think it's available for us yet. Oh, maybe it is. All right, let's see. Might be available. So let's go ahead. So the host here is going to be this long URL here that has .database.azure.com. And we can also check the connection strings. If we look at the connection strings, you can see the username. We can see the host, the port. It won't show the password here, thankfully. So that's still secured. But we can also, double check all of this in the connection strings as well. So there, we're connected. And, oh, there, I modified the wrong thing. So let's modify it here. Okay, so that's the host. That's the user. The password I overwrote in the other file. The database name is Postgres. That looks good. The next thing I need to do is take a look at the networking tab. And yeah, it did finish. Okay, great. So how, what are the access rules for the Postgres server? The default connectivity method is public access. And what you're supposed to do is add firewall rules in order to allow certain IPs. And you have a few options here. So you could allow your computer's IP. So I could add my current client IP address automatically. And so that means anybody who has this IP address, which could be more than just me, depending on how IPs are allocated around here, anybody who has this IP address would be able to access the server if they had the username and password. I could also say allow public access from any Azure service within Azure to this server. And that's useful if you're doing, an application to connect to it. And we'll see an example using that later. But it also means other people on Azure could connect if they knew the username and password. So generally, any of these options are not going to be your most secure option. Your most secure option is VNet integration. And that's what we're actually going to use when we deploy a Django app. That's putting your Postgres server and your app inside the same virtual net so that there is no way of accessing that Postgres server from the outside. That's the gold star we want to be going for. But for now, as we're just trying this out, I want to show the firewall rules because you might have some use case for it. So I could do all this. Now, the interesting thing is I'm inside a code space. So what is my IP inside the code space? It's actually not the same thing as this computer's IP. So what I can do is curl ifconfig.me, and that will give me the Codespace IP address. So I'm going to go ahead and add this as a rule as well. Okay, and hopefully that covers all my bases so that I can connect. And it is updating the settings right now. So we'll wait for it to finish updating the settings before we actually try to use it. Or we can just be eager and just try it anyway. Okay, so let's see, going back here. And also what I want to point out here is I have this if condition that says if DB host is not equal to localhost, then it adds SSL mode equals require. That's what I recommend doing whenever you're connecting to the production server, is to enforce SSL. It's going to work much better. All right. Successfully updated. Okay, moment of truth. Fingers crossed. Ta-da! All right, so yeah, it worked. Now what we could do is see if we can connect with SQL tools. So going back over to SQL tools, I can do edit connection. I do edit connection. Okay, so we're going to update. Let's go back to our connection strings and grab the host. All right, so this is going to be the host, the username. And for the password, I'm just going to have it ask on connect. This is how I'm avoiding showing you the password. And then you can see I've enabled SSL. So yeah, let's try out this. And I'm going to click on it and enter password. So going back to my password. Oop. And here we go. Gonna go ahead and expand these and take a look at the tables. And there we see restaurants too. And I can click on this and see that the noodle bar is in here. So I think that's really cool that we can have this full experience with Postgres from VS Code, from Codespaces even, including both local and Postgres. So yeah, and you can check the slides to remember how we did that. All right, so now we're ready to move on to Django. I'll take a little pause here to see if there are any lingering questions before we move on to making a Django app. Oh, how did I save the password without revealing it? Well, fortunately, hopefully you don't have to deal with this in your, because you'll be using not, screen sharing when you have a password. But what I'm using is secrets. Where do we go? Somewhere under here. So Codespace secrets. And let's see, was this the one? Using secrets. There we go. Editing a secret. Right, so settings and then the secret. So I'll link to this. So if you're going to be using Codespaces heavily and you want to take advantage of secrets, then take a look at this documentation. Oh, question is, can the .m file be encrypted? Yeah, that would be another nice approach. That's what we did at Khan Academy, is that we'd always have to decrypt the secrets file when we would start up our dev server. So that's a nice idea. Yeah, I think that seems like that should be totally doable. And you would just have to get the decryption key from your password manager, like your corporate password manager. Yeah, that's a really nice idea. Cool. All right. So let's go on to writing Django applications. We're going to be using Django framework. So shout out in the chat if you are a Django user already and so that we know who's got experience with it. I know Dawn is a big Django user, and Dawn is going to be keynoting at DjangoCon in Europe. So any of you Europeans maybe want to check that out. Maybe Dawn could link to that. So Django is a package for making Python web apps. It is commonly called like an opinionated framework. So it has, an idea, an opinion about how you should write your apps. And that can be really great because I think in a way it makes it easy to get started because you just know there's like this one way to do it. It can also be limiting at times if you want to take your app in a really different direction structure-wise than what Django's imagining, and you might find yourself fighting against it. That's generally always the tension when you're picking a framework, is that, if you pick a framework, you have to work inside that framework and you get all the, all the benefits of that framework, but then you might find yourself, with intention with that framework at points. There are lots of apps written in Django. When I first joined Coursera, it was written in Django. They since moved it over to Scala plus the Play framework. I believe Instagram is still written in Django, last I checked. Pinterest was originally written in Django, but then they found themselves, kind of struggling with the rigidity of Django, and they moved it to Flask. Eventbrite, I believe, is still written in Django. So many apps out there are written in Django. This is just a select few. It's a fantastic framework, especially if you're using a database. I think it's so much easier to use a database from Django than from Flask, in my opinion. So if I'm going to use a database in the standard way, I'm going to use Django. So if you do want to follow along with this part, this is the app, the sample I'll be using. This is actually one of our official Azure samples. And so you could go ahead and check out this one on Codespace or locally. And let me get mine open. Let me close some tabs here. Sure. Leave it. Boop, boop, boop. All right. I think this is it. Yep. Oh, I left it for too long. I'll restart the Codespace. But this is a restaurant review app. So we've built up to it. All those restaurant reviews we saw earlier. We are going to be making a restaurant review app using Django. Read the link. And yeah, recordings will always be available for all the sessions. Wait for it to load. Okay, so here we go. Here's our Django app. So generally in Django, it's confusing because a Django app is made up of apps or applications with each folder corresponding to an app. And the idea is that this makes Django web apps more modular. So you could bring in, different apps and they could, work together better. So it's a way of modularizing code, is to think about splitting an app into these apps. So inside this web app, we have only a single Django app, which is called Restaurant Review. And this is the folder for it. So each application folder is going to have a urls.py, views.py, models.py, and maybe some other files as well. So let's take a look at what this restaurant review structure looks like. So inside urls.py, we define all the routes and the views that they correspond to. So this is just defining routes and giving the names, giving the references to their view functions. So Django likes to separate things like this so that you have smaller files and so that there's more of a separation of concerns. So if your concern is figuring out, what the path mapping is, then you look at this urls.py file. So we see there's a route path for the index. We see there's restaurant details. We see there's routes for making restaurants, for handling the get and the post, and then also a route for adding a review. Now, if we go to views.py, then we can see the actual functions. So like inside index, we do a query to get the restaurants. We add a little bit of information with a review, and then we render a template and pass in the list of restaurants. So this is using the template rendering system, and this is a common part of most frameworks, is some ability to make templates and combine templates with template variables. And that's how we can have these dynamic pages that are different based off of different database results. So if you look at templates and you look at index.html, what we can see here is that we have this template language. And this is a very basic language, but you can do a lot with it. So we say like, okay, if any restaurants were passed in, then we have this table and we loop through the restaurants. So for restaurant and restaurants, we show the name of the restaurant. And we can also use this little, this is a template filter tag that does something a little bit special here. And that includes the star rating. So that's the idea of rendering a template if you haven't, used something like Django or Jinja Flask before. And then let's look at models.py. This looks very similar to the SQL Alchemy ORM code that we were writing earlier, but this is using the Django ORM. And so you can see from Django.db import models. This is what's really nice about Django is that the ORM is built into Django. So there is, one standard supported way of interacting with databases. You could pull in other ways if you really wanted to. Like if you wanted MongoDB, you could use PyMongo inside your Django, but it's going to be harder. So it's easier if you're just going to use Django.db. So here we define restaurant and it just has a couple columns on it. It's always going to create the ID behind the scenes because Django assumes you always want a primary key, an ID for each of your tables. So we don't have to add that, it's implied. And then there's our review. Okay, so that's the essence of a Django app. Let's actually run that app and, connect it to a database. So once again, in this dev container, I do have Postgres running again because I'm going to have Django interacting with Postgres. So we're basically building on top of that previous, that previous example, adding Django on top of that. So now we've got a Django app connecting to that local Postgres database. And the reason it's connecting is because in the configuration, so in settings.py, which is where you always put your Django settings, we see this, let's look for databases, equal, there we go, right there. Here we see the configuration for the database. So we see the engine is Postgres, and then we're getting DB name and DB host, DB user, DB pass, getting that from the environment. So once again, we want to make a .m file. It's not going to work unless we make that .m file. So I'm going to go ahead and make a .m file and just copy the dev container sample.m. Okay, so there we go. This should match the local Postgres server. That should work. And now we need to actually test that out. So the first step before actually running the app is to make the tables in the database. And this is known as running a migration. So we're going to run the migration by calling Python3 manage.py migrate. So I'm going to run that. I didn't install. Let me install. In most of my dev containers, I have it always installed, auto install the requirements.txt, but this one doesn't have that set up. So I need to explicitly install it. All right. And now let's try migrating. All right. So what you see is it actually applied a lot of migrations and made a bunch of tables. So that's because Django actually has all these default tables that it makes. So it makes admin tables, auth tables. It depends on what installed apps you define in your settings. But I use kind of the default setup, and it made all these tables. And then it finally made the restaurant review tables down here. Now, if we look in SQL tools, hopefully we should see those tables made. So we're going to expand this. Look at tables, and we see lots and lots of tables made here. Okay, so that's good. Now we should be able to run server. So we're going to do Python manage.py run server. And this is going to run the development server for Django. This is not a production level server. Here we go. Here is the app, and it doesn't have any data yet. So we're going to add a restaurant and San Pablo Momos, right? And then we can add a review. And scrum diddly, that's too hard. And then we'll look back here and we see our restaurant with our single 5-star review. It's all working. That's really cool. What I want to show you is that Django has this admin interface, and that's what part of what I think makes Django so special is the admin interface. So by default, it's at /admin. And it asks for a username and password. Now, I don't actually have one yet. I have to make what's called a Django super user. And the way to do this, I'm going to open a new terminal, say manage.py, create super user. And it needs a username. So we'll say Pamela. And then here's my email address. Y'all want to say hi. And then a password and a password. And you see it tells me my password is not a good password, which I agree. I'll use a good one on production. And there we go. So you do actually have to be super careful about your super user credentials, because this is you'll see that this admin is a big security risk. So let's see, my username was, I think, Pamela, and then my password was super secret. And I'm not going to tell you. But the thing is that admin gives you administrative interface for a lot of the tables in the database. And that's why you have to be really secure, careful, and keeping those credentials. Once again, you could keep it in Azure Key Vault. You could keep it in a corporate passage manager. Keep it somewhere secure. Rotate those credentials. You could also use something called Django Honeypot, which is a package that tries to detect people trying to break into your admin. And that's something you can just add in. You can also change what the URL is for your /admin so that it's not as easy to accidentally break into. So lots of things you can do in order to secure up this admin interface, and that you definitely should do. But that said, it's really cool. So if you do have a nice secure approach to it, it can be a really nice feature, because you can go ahead and do everything from here. The kind of stuff that I would do in PHP MyAdmin, if anyone remembers that, like a SQL interface. So we can take a look at the existing restaurants. We can add new ones. We can edit existing ones. And you can do a lot of customization of this interface. So when I was at Coursera, I spent a lot of time on our Django admin, even rewriting it entirely in Backbone.js at the time. You can do so much with this admin interface. And if you do want to customize it, the way you start is with just the admin.py file for that application. And you can say, different things you want to customize, like different widgets you want to use, how you want to stack things, lots of stuff you can do. I see love for Django admin. Thank you, Don. It's so cool. It's so cool. Okay, so there we've got Django admin. And yeah, so now I'm feeling good that it is working locally. We're able to use it as a user. We're able to use it as an admin. It's looking good. I think that we are ready to host it on Azure. So I have the same diagram from before. We have a lot of places we could host a Django app. I probably would not put a Django app on Azure Functions for performance reasons. You could technically do it, but once again, Azure Functions should be really fast to start up. And Django's going to have a bit of startup time because it is, a framework that's doing a lot of stuff. So probably not the best fit for Azure Functions due to, wanting to really have those be super fast. Azure App Service, really good fit. I mentioned that Azure App Service actually knows about Django, so we can look at the code base for Azure App Service and see Django mentions. So it tries to make it really easy to deploy Django apps. I've also deployed on Azure Container Apps, and that's pretty cool as well. I haven't tried Azure Kubernetes Service, but it should be possible. We are going to use App Service again because it is a nice fit. But we're going to use App Service with a few more things, right? So in the first session, if you're here, the first session, we deployed FastAPI to App Service, and that was basically it. We had App Service, we had an App Service plan. This time, we want to be deploying an App Service app and a database, and we want to do it the secure way. So we want to use a VNet, a virtual net. We want to put both the Postgres server and the web app inside the virtual net. We'll give the Postgres service what's called a private DNS zone that enables the web app to talk to it as if it had its domain name. And we give each of them their own subnet inside the VNet. And so this is roughly what we're going to set up. And, this can look a little complicated. This is the big drawback. This is a little complicated. It totally is a little complicated. But luckily, we have done the hard work for you. And we have multiple ways of getting this deployed and off the ground. So if you're worried like, oh, I don't know how to make a subnet, totally cool. We did that for you. So the main ways I'd recommend is you could use Azure Portal. There is a web app plus DB template that you could use that makes a VNet. You could do it all from the Azure CLI, or you can use the Azure Developer CLI with infrastructure as code. We're going to do that third option today because it's what I really love when I'm deploying a lot of resources at once. I think it makes it the easiest to deploy a lot at once. See all my hearts. So let's talk about AZD. This is a new CLI. It only came about in like the last 8 months. So it's super new. It's still in preview mode, but hopefully, going to be generally available soon. And once I discovered it, I just loved it. I don't really like using the portal or the other CLI. I just love using AZD, and my colleagues will attest that I'm the AZD fangirl on the team. But I just think it's just a really nice approach when you're deploying these complex architectures. It can deploy all these resources at once, and also it can deploy your code afterwards. So the goal of this tool is to help with all the steps of the dev cycle. So the first step is to create all the resources, right? So to create the app service, create the VNet, create the key vault, create the Postgres, right? Create all of those in our Azure account. The next step is actually deploying code up to whatever's going to host it, right? So deploying it to app service. And you can actually do both of them at once in AZD if you use this AZD up command. We can also add on CI/CD pretty easily with this command here, and then we can do some monitoring. But the goal is to really cover the whole life cycle of development and try and make it easier. All right, let's try this out. Okay, whew. It's always nervous whenever deploying. So we're inside the dev container. The dev container should already have AZD installed because in the Docker file, I have this line here, which is one way to install AZD. You can also use winget, NuGet, Homebrew, all these different ways of installing it. But this is how I do it for the Docker file. And yeah, so that should mean if I type AZD, it should know about that command. Okay, it does. And then if I look here, I've got an azure.yaml, which is one of the files it needs. So I'm just going to go ahead and first I'm going to log in. So AZD auth login. And I'm going to log in on my personal account because it's just easier. I don't have to two-factor. I guess I couldn't enable two-factor for my personal account, but my phone is my webcam right now, so I really can't two-factor. So enter the code. Okay. In Codespaces, you have to do this device code login where you enter a code. If you're local, it's much easier to log in. But in Codespaces, you do have to jump through tabs in order to log in. All right. So it says I am logged in, and AZD detected that and says I am logged in. Very good. Now I'm going to type AZD up. And I have to enter a new environment name. So this is just going to become part of the name for everything that gets made. So I'll go ahead and say, Django May 2nd. Then I select a subscription. I only have one subscription on my personal account, so that's easy. And now a location, I'm going to go for East US because I have had greater success with that generally in life. And now it starts doing the work. So let's see what it's doing. It packages up the code it's going to deploy. So that's the AZD package step. Now it's provisioning, and you see it's downloading the bicep. So what that's talking about is bicep. Bicep is an infrastructure as code language. And I'm going to show you it now because that's how this all works. So there's an infra folder, and it has a main.bicep file. And this is declaring all our resources. We can see here it creates a resource group. So the first thing we have to do is make a resource group. So we make a resource group using that name, and you can see it actually made it already. And now it's also made the virtual network and the app service plan. So we will watch as it, as these things come in. And those are all defined in this resources.bicep. So here you can see the virtual net, and you can see that it has a subnet for the database. It has a subnet for the web app. And, it assigns those. We have a private DNS zone, which is connected to the network. And there's another aspect of that private DNS zone. Then we have the app service itself. And here you can see it's actually going to deploy on Python 3.10. I could change that to 3.11 if I wanted. And it does have its own command line startup script. So remember what we overrode in the FastAPI session? We can override that in Bicep. So basically anything that we could have done from the portal, we can do from this Bicep file. And we're doing it in a declarative way. So we're declaring like, okay, this is what the configuration should look like. So Azure is going through and seeing, what's different and what it needs to change. It says like, oh, there's no VNet yet. I'm going to make a VNet. Oh, it's not 310. I'm going to make it 310. So it's figuring out what it needs to add according to this file here. It doesn't actually take away anything, which is different from Terraform if you've used Terraform. So by default, it doesn't take away. It just adds, but that usually works out well. We've got some app setting here. So I've got my connection string. And so these are going to be randomly generated for security reasons. And and then we've got app service plan. We've got an analytics workspace. Then we've got the Postgres server using that B1MS SKU, which is the cheaper SKU. And here we've got the login information. And yeah, this is a lot. There's probably, let me check to see what people think of Bicep in the chat here. A lot of people look at Bicep and say like, oh, do I need to learn Bicep? Like, is that something I need to learn? I don't think you necessarily need to learn Bicep. Our goal is to have lots of these Bicep templates available for you so that if you do want to use tools like this, that you can take these templates and maybe just make little tweaks, but not have to necessarily become a Bicep expert, because not everyone necessarily needs to learn Bicep. But what I really like about it is like we can check these files into source control. We can have these reproducible deploys with complex architectures. We can do linting on them. So I actually have a script that a linter that checks for both style issues, but also security issues. So I have a security linter that I can run on this and find out, like, oh, hey, you should be, using this more secure method for your database. So that is really, really cool, right? The other big advantage is that if you declare all your resources like this, it's actually faster for Azure to deploy them because it can figure out which things it can do in parallel. So it says like, oh, if these two aren't dependent on each other, it can create those two resources at the same time. So you can have faster provisioning than if you're just doing a command line script. And here you can see it's made quite a few of the things here. We can also look at the parameters that get passed in. So you do see that it is randomly generating the password. And, that's obviously important to randomly generate it. In my other templates, I actually store this in a key vault. So there is a way to store this in a key vault. I think this one doesn't store in the key vault, but I would recommend doing that. And you can always look. I have tons of examples on my GitHub. So if you're looking for a particular template, if you like the looks of AZD, you can see on my GitHub a huge number of projects, and they have the little check mark next to them as to whether they support AZD. Most of them do, because I love AZD. You can also check the AZD templates gallery, and most of my templates are in there as well, and also my colleagues' templates are here, and community templates too. So you could submit an AZD template here. If you love Bicep, you love what you're seeing, submit a template. All right, let's see. Do we have any questions as we wait for this to finish? So Azure.yaml, I'll just point this out. This is another thing that AZD requires. The big thing is that it says what it's going to upload. So here it's actually uploading the whole folder. Usually I put stuff in a subfolder, but here it's going to upload the whole root folder it knows it's Python, and then it knows it's app service. So this is how it knows what code to package up. This has to do with the packaging. Any questions on what we're seeing here with AZD? Yeah, I see a lot of talk about Terraform in the chat. Bicep is really similar to Terraform, and you actually can use Terraform with AZD. So you could, if that was something that was important to you. AZD does support Terraform. We don't have nearly as many examples in Terraform. We tend to refer Bicep because it is specialized just for Azure, and so it's more likely to support the latest versions of things, and just to work really well. But it is a possibility. Thank you. We can also watch this deploy happen in the portal. Oh, let me do it in my actual personal portal here. That's where it's happening. And I think it's almost done because it just made the Postgres server. And generally, in my experience, that's the slowest part of this process, is that Postgres server. So we can take a look at the, as it's doing. You can see all the different resources it's provisioning, and you can actually see that it does it in parallel. And yeah, it actually did create everything. So it created a resource group, a VNet, app service plan, app service, all this monitoring stuff, and then finally the Postgres server. And now what it's doing is the AZD deploy step, where it's bundling up that code and zipping it up and sending it to the Azure server. Great question from Jason Yu. What is the difference between AZD and the Azure CLI? So the Azure CLI, if we were going to do it with the Azure CLI, it would look a bit different. Let's see. Can I just write some? Well, I don't want to make a new file here. But like Azure CLI, create, web app. Just want to look at some example code just to show. Right, so you'd have to, so this is a good example here. So if you're going to use the Azure CLI, you would be, running commands for pretty granular things. So you'd run a command to create the resource group. You'd run a command to create the app service plan, then to create the web app, and then to create the Postgres, and then another command to connect them together. So usually it's going to take you a lot more commands in order to create the same thing. And then if you were going to try to, replicate that thing, like if you wanted someone else to be able to deploy the same thing, you'd need to share that script with them, right? And say, oh, here's the script I use. Here's the parameters you can change. Here you go. Whereas the Azure Developer CLI, it only has a few commands. So it has, AZD provision, AZD deploy, AZD package, and AZD up, which does everything. And it only has those few commands, but with those few commands, they use the Bicep files so that you can create anything. So they're actually really different CLIs. There was some talk about renaming AZD because I think there is confusion between Azure CLI and Azure Developer CLI. I still don't know if they're going to rename it. We'll find out hopefully in the next few months, because they are actually pretty different. So I would think of AZD as, with a single command plus infrastructure as code files, you could put up your entire application with many resources, deploy the code to it, and also set up CI/CD. So it's trying to take care of the whole workflow. All right, so it's currently uploading the deployment package. Let's also take a look at the startup script. So you remember in resources.bicep, taking another look at, this is our app service configuration. So you see it's Python 3.10, and it says the command line should be startup.sh. I don't know how to pronounce sh. But that is a shell script that it's going to run. So app service does know about Django. So if we didn't give it the command line script, app service actually would run a default Django startup script, and it actually would work, but that doesn't include migration. And I wanted it to do migration before running the server. So that's why I have a custom startup script, and it is right here. And here you can see it first runs migrate, and then it runs to Unicorn. And this is actually basically exactly what app service would do. If you didn't provide your own startup script, it would run this to Unicorn command here. But I'm also, doing a migration first to make sure it has all the tables. It's up to you when you do migrations. There's different workflows for when you do migrations. This is just for a demo, so I'm just doing it on startup. You could do it outside of your deploy flow as well. Okay, it deployed. Let's check it out. Fingers crossed. Boom, boom, boom. Application error. Okay. Now it could be that we're just too fast. So I'll go ahead and open up the log string for the deployment. And also I'll just hope that it's just that we're too fast. I think that's actually pretty likely, but let's go ahead and open it up. Where is my resource group? Django May 2. Okay. Gonna go to the app service. Gonna go to log stream. It's good to know how to debug things. Let's see if we have to debug anything today. I think it might have just been too fast. Let's see. Pulling image. Hi, Jay. Thank you, Jay, for joining. Let's reload that. Initiating warm-up request. Initiating warm-up request. Oh, you can also get your lock stream in VS Code. Maybe Jay can remind me the command to do that. I know I've seen him do it. Jay has a bunch of great sessions on YouTube on the Microsoft Developer channel where he deploys to Azure using different mechanisms. So if you want to see a variety of workflows. Haha, it did work. We were just too eager. Yes. I didn't really want to have to debug that live. But I do actually, I'm pretty sure I have a blog post, Pamela Fox debugging Django apps. I do have a blog post. I try to blog things because otherwise I forget them. So if you are debugging Django apps on Azure, I apparently have a blog post about it. So it did load and it doesn't have any data yet. So we could go add in more data to it. But yeah, so it is working, which is really cool. So that is the AZD process. Yeah, we did need to have those bicep files in order to be able to do it. But I was saying we're trying to create lots of templates so that you can just find the bicep that works for you. Let's talk a little bit more about bicep. Oh, and we could also configure the GitHub workflow. So you can see like on all my AZD repos, you'll see that there's a Azure Developer CLI workflow. And every time I push to main, the way I've set it up is that every time I push to main, it does the whole process of doing the deploy to AZD. And yeah, so AZD makes that easy to set up as well. So here we have the bicep language. Okay, tips for writing bicep files. There is a bicep extension for VS Code. Install that. I have that in most of my dev containers. There's a bicep reference. Always want to have that open. It also has examples at the bottom of each of the bicep pages that you can look at those examples. Definitely check the AZD templates gallery. and you can filter this for whatever you're looking for. I always have it filtered to Python, but you can filter it down even more. So if you want to do Python FastAPI and then you change it to and, so this is all the Python FastAPI examples. Of course, we're doing Django right now, so let's do Python Django. And we see these two examples here, but there's going to be one more template coming up very soon from Jay later this week. You can also search GitHub for examples. So, you can search by bicep language and find other examples. And I have a blog post here that has more tips for writing bicep files. I also have a talk from CitusCon where I specifically walked through how to write the bicep file for Postgres in a site at VNet, since that is pretty complicated. So if you really want to get into the nitty-gritty of bicep and understand it, you can watch my CitusCon talk. It should be on YouTube very soon. It's already up as the live stream, but it should be cut up on YouTube soon too. Let's look at a few more examples of Python plus, Python plus databases. So here we deployed inside the VNet. That is the best practice. So please do use a VNet if you can. If for some reason you can't use a VNet, it does increase your costs by some amount. I think it somewhat doubles the cost because of because it's based off requests, what's going through that VNet. So it does affect costs. If you don't have the ability cost-wise to use the VNet, or for some reason your data is super not private, then you also have the option of using firewall rules. And you saw us use that earlier today when I was connecting from the code space, and I just put that IP on the allow list. So if you do want an example of that, I have another repo that uses firewall rules and stores the admin username and password inside an Azure Key Vault. So you can use that repo if that's more the setup you want, but please do keep security in mind always. I have another example which uses Redis as well as Postgres. So Redis is kind of a type of database typically used for caching. And in Django, you can configure caching, and you can do caching on the view level, the template partial level. You can do it on all sorts of levels. So you could use Redis, and we have an Azure Redis. So you can use Azure Redis as a backend for cache. You can also use Azure Redis as a backend for Celery. Celery is a message passing thing. So it's useful if you want to queue up a bunch of messages and then process them at a different pace than your normal app. So and then also this one uses Azure storage for static assets and media uploads. So it has a bunch of stuff going on. It's based off the cookie cutter Django project. So it is actually it's a fork of that. It has support for Azure. If you're interested in all that stuff, then do check out that example. Another example here is App Service plus Azure storage for static assets once again. Also plus Azure Monitor for application insights for sending the logs there, and Azure load testing. So if you're really concerned with scale and making sure that your application is going to be able to handle the load, and that you've picked the right tier for your Postgres and the right tier for your app service, then you could use this one that has Azure load testing and run some load tests and decide, oh, maybe I should, update, use a higher tier or a lower tier, right? We don't want people overbuying. You shouldn't have to, be using a really expensive tier if you're not using all of that compute, right? We're all about not wasting cloud resources, which is why actually that's a good point. One thing we should do after we put it up is take it down. So I'm just going to run AZD down because I'm not using it anymore. And it is going to, it's now going to check what it can delete, and I need to confirm, and it's going to delete all those resources. So it's always important to take down any resources you're not using, and because one, you don't want to spend any money that you don't have or don't want to spend, and two, we don't want to waste cloud resources, right? From an environmental perspective. We also have the example of Django plus Azure Container Apps. This is the one that Jay made, and this will be in the template galleries soon. And this is what we used at PyCon for the PyCon lab. And so there's a really cool lab that you can follow. Let me show that. So here, if you go to lab, Jay wrote this whole lab here. So you start on the README, and then it walks through the project. through testing. And here we've got playwright test, which is really cool. I actually added the playwright test for this one. So we're not talking about playwright today, but if you're interested in playwright, that's in this repo here. It's a browser automation library so that you can do tests against the front end of it as if you're an actual user. And that's a really nice thing to do for web apps. Deploying locally and then deploying to Azure and then tear down. So this is a great lab and demo to work with as well. Let me post a link. I see a question. What was the delete resources step? Yeah, so delete resources is what I'm doing. So the tear down, you can call it different things, tearing things down, cleaning up, deleting resources. We always talk about it in all of our Azure tutorials because we don't want you to accidentally keep anything, going that you don't need. So you have multiple ways of doing it. One is that if you do use AZD, you can run AZD down. You can also go to the portal. Let me go to a portal. Find something I don't like, don't want. We've made a lot of resource groups today, y'all. So I'm sure there's something we could delete here. And so if we find something that we're not using anymore, it's like this one. And so I can delete an individual resource. I can also stop a database, and that actually stops the payment for it. But I could straight up delete it. Or I could delete the whole resource group. So I'm going to go ahead and delete that. So yeah, generally clean up your app if you're not using it anymore. Like if you're currently in the prototyping phase, in the learning phase, make sure to clean up what you make so that you're not accidentally running stuff in the cloud that don't need to be running and that you avoid any accidental costs. Cool. All right. So we actually managed to end today's session, I think, or not today's session, the middle session, a little bit early. So that means we do have time for additional questions or requests from y'all in the live audience. So is there anything more we want to talk about in terms of AZD, Django, Postgres, Bicep, all of that? Let's see. Still going down. Anything? Let me see. So Kevin asked, are there Microsoft open source projects that are participating in Hacktoberfest 2023? Oh, that is a little early. I know that last Oktoberfest, our colleague Anthony ran VizCode Pets, which is his extension, which is amazing. I don't have it in my dev container. I apologize, but it runs pets inside your VizCode. And it's a very popular, look at this, 400,000 installs. It's a very popular extension because it's just cute. And it was actually a really nice starter project for Hacktoberfest because, you can always add a new animal and so you can look and see how other ones are done. So I imagine he'll probably be, running that again for next Hacktoberfest. And yeah, I don't know what my other colleagues are planning to run. I really want to be developing some stuff to do accessibility testing in the next few months. So if I have like a PyTest plugin for accessibility, that would be really cool to hack on. So yeah, we still have 5 months before Oktoberfest. So we'll have some time. But in the meantime, install VizCode Pets and get ready to add a pet. Let's see. More questions here. Okay. Yeah, where can I store my custom log messages that I wrote in my API so I can later go back in time and explore the logs? That is a great question and one that I kind of glazed over, and that wasn't very good of me. So let me look to see. No, I'm going to open up Tony Maloney's Django on Azure because he actually does have it set up correctly. So let me find where he has it set up. Project, maybe here. Telemetry, open census. Okay, here we go. So if you want to actually, integrate your logs with Azure Monitor and be able to, get back logs, later, the log stream's not very nice, right? We saw the log stream. It works somewhat when debugging, but it's not a structured way of interacting with your logs. So what you want to do instead is use OpenCensus, or up and coming is OpenTelemetry. Jay has actually done a lot of work on our tutorials around that. So Jay actually knows a little bit more about that. But on Azure, we do have a tutorial about integrating OpenCensus into your Python application. So I'm going to go and link to that. And yeah, so it shows how to do it for Flask, how to do it for Django. Don't remember if it shows it for FastAPI, but we definitely have some examples in the templates gallery that do it for FastAPI. So that is what you want to do. You can see it here for Django, where we set up some settings here to tell it what sampler it's going to use and what exporter it's going to use, and we give it a connection string, and that way it actually has the permissions to upload to Azure Monitor. So that's generally your approach, is to integrate OpenCensus or OpenTelemetry, and that way you can get it from Azure Monitor. And then you get actually really cool tracebacks. You can get full Python tracebacks in Azure Monitor if you set this up correctly. And it is, so for FastAPI, I can show you that it is on the to-do samples here. So let's take a look at this one. This one's on app service. And in their source code in API, it is in, this one, here we go. So what they do is they use the FastAPI startup event. This is a special function that only gets called when the FastAPI app is starting up, and it doesn't get called on every request, just in the startup. And in that startup event, then they configure the Azure Monitor trace exporter, and that way it will be stored there. So yeah, so Django example, FastAPI example, Flask is also covered in the documentation. That's a great question. Thank you. Let's see. I think I saw another. Okay. Yeah, we had a question from Mustafa. What is the difference between Postgres and MySQL? That's a very good question. So I think you can also use MySQL on, can we use MySQL on Azure? Azure database for MySQL. So you could also use MySQL on Azure. So MySQL, I'm trying to, because I used it for a long time, right? I don't think did MySQL start off open source? Maybe somebody can help me out here. Oh, I know it was named after someone's daughter, which is really cool. MySQL has been around for a long time. I feel like it wasn't quite as open source. Yeah, look at this big lock. I don't think it has quite the same open source story as Postgres. Somebody can correct me if I'm wrong. And so I think because of that, that's why there's just a lot more community around Postgres, and why Postgres tends to have more of an extension ecosystem. But MySQL, I mean, I've used it for lots of things and can work quite well. So it could just, depend what it is you need out of your SQL database. And on Azure, you should be able to pick from most options that people have mentioned. But yeah, that's what I know about those two. Oh yeah, MySQL was acquired by Oracle, right? So my brother works for Oracle, so I guess I should ask him. He also got acquired by Oracle, actually. Let's see, MariaDB. And MariaDB is also on all these things. If we just search for on Azure, we also have Azure database for MariaDB. So we're really trying to have all the options here. Cool. All right. Well, I think we're at a good point now, and we'll have, I think, 13 minutes before our next session. So this is probably a good time to take a break and, eat a snack and all that stuff, and then come back for our final session, which is going to be about containerizing applications and deploying containers to Azure Container Apps. Okay, I think we are back for session 3. Hello, everyone. Everyone back from getting your lunch or midnight snack or whatever it is, wherever you are. Yay. All right, we are back. Let me share these slides in the chat for you all to get the URLs. So for our final session today, congratulations to everybody for sticking with us. I know this was a long day with lots of Python stuff here. Final session, we are going to be talking about containerizing. And we have actually talked a little bit about this throughout today because we've been using dev containers. And so I've been showing the containers a little bit there. But now we're really, really going to talk about it because we're going to actually use containerization as a way to deploy Python web apps. So we'll talk briefly about, what actually is Docker, what are containers, learn a lot of terminology. Then we'll containerize a simple Flask application that doesn't have a database and host that up on Azure. Then we'll talk about containerizing with databases and contrast how to do that locally with how to do it in production, because it actually is pretty different. Let's start off with talking about Docker and containers generally. So the goal of containers is having a standard way to package up an application with everything it needs. Its Unix environment, its language, its packages, package all of that up so that we can run that container anywhere. And containers, we call them containers because they're very similar to shipping containers. When the shipping container, the standard shipping container was invented, suddenly shipping became way more efficient because all ports could agree on what size the tools were going to be to deal with these containers and what size the ships were going to be. They all could support this standard container. And that's what Docker containers are at this point. It's it's like a standard for bundling up an application so that it can be run anywhere. And this is really nice when it comes to, cloud development, because if you can containerize your application and if then you can work with any cloud provider that knows how to run a container. And at this point, pretty much all the cloud providers know how to run a container. So there's a big benefit there for all of you from a cloud portability perspective. Of course, we'd love for you to run on Azure, but if you are able to containerize, it does give you more flexibility that if for some reason you wanted to deploy somewhere else, you've got that container and you could put it somewhere else. Or just put it some other container option in Azure. We've got that flexibility. So that's the goal. So how does this work? Well, we've got the Docker engine, and I've actually got it running on my machine. And you can tell if you can see this little whale up here. Docker desktop is running. So I've got this running on my Mac, and this has the Docker engine that is running, powering that desktop. So on my machine, I've got the Docker engine running, and that Docker engine can run multiple Docker containers, and each of those containers is an isolated environment. So they, each have their own application code, their own libraries, potentially their own version of Linux that they're built on. So that way it's really, you could have one container that has a Django app and a Postgres database. You could have another container that has a Rails app and a MySQL database. And, they wouldn't step on each other's toes at all. Or maybe a better example is you could have one app that was Python 3.9 with Django and, another app, Python 3.11 with FastAPI. And it wouldn't matter at all the fact that you had different Python versions because they're in their own environment. They're not going to conflict with each other in any way. So that, that's the goal, that's the dream. And you can see in my Docker desktop, I do have multiple containers running, and I can run them all at the same time and they don't step on each other's toes as long as I have enough space. I do run so many containers that I actually do run out of space in my Docker desktop, but that's because I'm like a container addict. So the benefits of containers is that if we're able to containerize our environment, then we can have more consistent environments. So we can have, make sure that all of the developers in our company can spin up the same kind of environment, right? So that the first day at your company, you're not spending the whole day trying to figure out how to get it installed on your machine. You just download Docker Desktop, run that container, and you're good to go. It also means consistency with your testing environment, like your QA environment, your staging environment, and your production environments. We're trying to get as much consistency as makes sense between these environments so that there's less issues, right? So that developers can get started more quickly, and so that we discover any bugs that could happen, discover those earlier in the process before we get that container to production, right? So the closer that the containers are to each other, the more likely it is that we're going to find those bugs early. And that's always a dream, is to find the bugs before our users find them. Another advantage of containers is application portability. So if it's easy to run, a container anywhere that supports Docker, well, then it's, easy to put it on new hardware. So if, something happens, a tornado rips up a data center, no big deal. You can just run that container on hardware in another data center. And another way to think of it, tornadoes aren't so pleasant, is that it's easy to scale. If you need to be able to have more nodes handling your containers, you can run your container easily on lots and lots of machines, right? And then finally, another benefit is efficient hardware use. So we have these, powerful machines in the data center. We may not need to use a whole machine to run, a little hobbyist app. We could actually use a single machine with all its CPU cores. We could use it to run multiple containers. So it's an efficient use of hardware. So there's an environmental perspective to this too, is that this is actually a more efficient use of existing hardware to be able to slice and dice it. So some terminology here. Docker, when we talk about containers, we often talk about images. The container image is the package that includes everything that's needed to run an application. You can see, let's look at my Docker desktop again. So in my images, you see I've got a Postgres image, I've got a Python image. These are images that don't have any apps, but then I've got images specific to my application. So I've got one for my Django quiz app. I've got one for, the Flash server. So these are container images that have everything needed to make this application. You can actually see the size of them. So a simple Flask container is about 900 megabytes. It may be possible to optimize it, but that's what mine came out to. The Python image, this one here is like 920 megabytes, actually pretty similar. That's interesting. Postgres is 400 megabytes here. So you can see that, they take up space, and they actually do have all this, the application code and dependencies bundled inside. And you can read like lots of interesting posts about how to optimize your image size if you want to be able to do that. So we have the image, and that's the software package. And then there's an actual container is when you run that image, and you could run that image multiple times. So the same image could become multiple containers, right? So here we've got my images, and then we've got containers. And in theory, I actually could be running the same image as multiple containers. So that's the difference between image and container, right? We take the image and use that in order to create containers. And here's an example, just to visualize that you could have multiple containers run from the same image. So if we wanted, like scale out our Django application, we could run a bunch of containers on, multiple CPU cores or across multiple machines from that same image. Now, where do we find images? Where do we store images? You typically store images in a registry. There are both public registries and private registries. And that's where you can store and share images. The most commonly known one is Docker Hub. That has what's known as the official images. So we can go to Docker Hub here. And if you scroll down, we can see the official Python image. And that's where I get my Python image from often. Also the official Postgres image. So these are a bunch of images where if you know what you want is Postgres or MySQL, you're probably going to want to start with this image because they've already figured out how to set up the, the Unix box for that piece of software. There's also other container registries that you could use for storing, your particular images. So Docker Hub is very often used by, open source communities for the official images. It's also used by, corporations, but we also have a GitHub container registry, Azure container registry. That's what we're going to use today. AWS and Cloud have their container registries. There's lots in them. You could run your own registry if you really wanted. But the point is that there's somewhere that you can get images from. And when you are creating your own image, you need to decide where you're going to put it. And you need to consider security. Like, is this an image that, what are the permissions on this image? How are you going to prevent other people from accessing this image if that's something that's important for you? Now, inside an image, it actually is made up of layers. So most images start off with a base image, and then they add layers on top of it. So for example, your base image could be, Ubuntu, some version of Ubuntu. And then you could, install Python on top of that Ubuntu image. And then you could install Flask, the Flask package on top of that. And then finally, you could, install, actually just copy your application code over. So these would be layers of the image. And the reason this matters is, I think it's important to note, just because Docker does try to cache each layer, and it looks to see when things have changed to decide whether to rebuild, a particular layer. So if something changes in layer 1, it's going to have to rebuild everything from layer 1 to 3. But Docker does try to do some sort of, smart caching of layers in order to speed up builds. And we'll see this more when we actually build an image. I see some good questions here in the chat. So yeah, what is the smallest base image for Python that you run in production? Yeah, that's a good question. There's like Alpine Slim. And so that's a good thing to look at. If you look here, what you can see is the tags, and you can see all the things available, and then you can, read down and see what the differences are between them. So talks about the variance, right? So that's what I would look at it. So I was trying to decide, like, oh, do I only need Slim? And that might be a better option. There's, this one here. So I would first read through this page to decide. I don't have a strong opinion myself because I haven't played with that in particular. But if anyone has more thoughts, please share them in the chat. Good question. All right. So now let's actually let's work on a Flask app. Okay. So we're going to be working on this Flask app. Let me share the link in the repo. Share the link on YouTube. There we go. Okay. So this is a very simple Flask app because we don't really care about the app. We just want to get it containerized. So I should have it open in this code space here. Let's take a look. So we've got app.py. It just has a couple routes, really straightforward. There's a static folder and a templates folder. Requirements.txt just has Flask in it. But the first thing we want to do is to remember that if we just run this app using the Flask command, it's running the development server. We want to use a production level server with Flask. So once again, we are going to use gunicorn because we want a production level server. I'll demonstrate what it looks like when we run this app first. Oh, that's not what I want. Let's go here. All right, and let's open this up, see what the Flask app looks like. And here we go, very simple Flask application. If you're looking for the repo, I put it in the chat, just a few messages up. Okay, now we notice here it's this big warning that says this is a development server. Do not use it in a production deployment. Use a production WSGI server instead. Okay, so we're going to heed that big warning and use gunicorn, just like we used for FastAPI in the first session. So first we need to add gunicorn to our requirements.txt. I'll add it here, the latest version. And then we're going to need to reinstall our requirements.txt. Okay. And then let's just run this with the the basic command. So gunicorn, it's going to get the app object from the app file. This one's just going to run with 4 workers and bind to port 50505. Let me open this up. All right, so that is working with gunicorn. But of course, we want to add a gunicorn.conf.py. This is a much nicer thing to do to configure the application, because then we can come up with the number of workers and threads based off of the CPU, the number of CPU cores. So that's what we're going to use for our gunicorn configuration instead. And that's going to be much better when we deploy it to Azure, because we might pick different tiers for our, container app, which would have different numbers of CPU cores. So now I can just run the gunicorn command, and it will automatically find gunicorn.conf.py as long as you name it exactly that. All right, and you can see it's running with 5 workers because this code space has 2 CPU cores. And so it's 2 times 2 plus 1 is the recommended formula from the gunicorn documentation. We open this up, and okay, it's working. Cool. Now we're ready to containerize it. So the steps for containerization is to 1, write a Docker file, 2, build an image from that Docker file, and 3, run a container using that built image. So what's inside a Docker file? It typically starts off with this line here that says the base or parent image. So this one here, I'm just doing it from Python 3.11. I didn't specify any of the, the variants. There's a discussion in the chat about which variant to use. So here I'm just saying 3.11, and I didn't even specify a subversion. So I'm just getting, whatever 3.11 is actually pointing at, and you can check the Docker Hub to see which subversion that's going to pull. Then I'm going to install additional software. So we could do that with our requirements.txt. Here we could also do it just pip3 install FastUnicorn. So we use this run command. This is a command you can put in your Docker file. So we say run, and then we put some command to run. Then I want to get the actual application code inside. So I have this workdir command. Workdir, see this one? So workdir says create this directory and then set this as the current working directory. So from then on, all the commands that get run are run from inside that directory, as if it's inside that directory. So we create the code folder, set that as a working directory. Then we copy all of the code. So copy dot. So all of the code inside this project gets copied to that code folder. Then we expose a port. So this is my usual Flask port to expose is 50505. And then finally, we have the entry point command. This command is only run when the container is launched. So it's not actually run as part of building the container. It's run when the container is launched. So it's going to be when it's actually run. And it's specified in kind of a funny way. It's specified as a list. So it's as if you take your command and then you kind of split it by white space and then make a list of it. And this is because this way it doesn't have to do parsing, which I don't know, it's a bit funny to me, but this is how you do it. There's another way of doing it as well, but this way it works pretty well. So that's our entry point command. Okay, so those are the standard components of a Docker file. Here I have the whole file, and it's slightly different, so I'll explain what I did differently here. Okay, Docker file. So I just make Docker file. I need to spell it, capital D, Docker file. And this does have one slight difference here, where the first thing I do is copy requirements.txt and pip install from requirements.txt, and then I copy everything. And this might seem a bit funny, like why am I doing this separately? I could have just copied everything and then installed. The reason for this is that caching, the layer caching that I mentioned earlier, if by separating this, then if the requirements don't change, then Docker can choose to reuse this step from the cache. And this step can actually take a long time, right? Installing requirements, that could actually take a long time and space. So if this doesn't change, it can just reuse that from the cache. That's why it's very common to split up these steps and first copy over the requirements.txt and install from that, and then copy everything else, because very frequently your code is probably going to change, right? That's the thing you're iterating on the most quickly. You're not changing requirements.txt quite as often. So this is a little thing that can help with build times. Okay, and then everything else is the same. We do also want to add a Docker ignore file. So just like we have, Git ignore files to tell Git what not to check in, we can also have a Docker ignore file to tell Docker what not to build. So let's see. Oh, that's not what I want to put in there. Here's what I have in this. Okay, so I'm going to ignore all the Git stuff. I'm going to ignore any virtual M stuff if I've been doing a virtual M. I'm going to ignore all the PyCache files. So these are all the intermediary files that Python makes. This is what I added to my Docker ignore. We could, ignore other stuff too. Like we could also ignore, we don't need dev container, in our build file. So whatever makes sense for you to add to your Docker ignore, just make sure you do that, because you don't want to unnecessarily copy something over you don't need. All right, so now we get to build the image. So there's a couple ways we can do this. We can use the Docker command tool, and I'm able to do this inside the code space because I have this feature called Docker in Docker. So this is a little bit of Dockerception here, because remember, a code space is actually a Docker container, and I'm about to build a Docker container inside a Docker container, which is like a little weird, but it's good for learning, right? So yeah, this is possible because I have Docker and Docker. That means that the Docker CLI is actually installed in this code space. So if I, go and type Docker here, we'll see that this command exists, and I can see all the possible commands to run. I could also run this locally. I've got the Docker, I've got Docker command locally as well. So this should be able to work wherever you have the Docker CLI. And if you download Docker Desktop, then you should have the Docker CLI. One thing I should warn you is that if you have a Mac M1, this is not going to work on your local machine. That is why I'm using Codespaces today, is because this actually wouldn't work inside my M1, because on an M1 machine, it has to use an emulation mode in order to run things that aren't built in the ARM64 architecture. And this is actually bringing in AMD 64 due to AZD only supporting AMD 64 right now. And it just gets too crazy when the Mac M1 is trying to emulate AMD and also have Docker inside Docker. So it's just too much going on. So this does work in Codespaces, but this won't work in the emulated mode in M1. If you don't have M1, don't worry about it. Your life is awesome. It's just if you have M1 that there's a tendency to run into issues. But everything works in Codespaces here. Okay, so there we go. Now let's do a little build. So I run Docker build --tag FastAPI. So we give it a name and a tag. So I'm naming it FastAPI, and it's going to default to the latest tag, but we could also give it an explicit version. If you look on this, Python, you can see all of these tags. So Python is, like the name of the image, but then it has all these tags. So tags are what you're going to use for versions of your image. But the default tag is always latest. And so that's what it's going to make if I don't specify a colon after it. I could also explicitly say latest. All right, now it is doing the build. And you can see it's pulling down the layers of the Python image. And you can see how long it takes to pull down those layers. And you can see how big the layers are. Some of them are really big, some of them are really small. So I'll just check the chat as it's running. So a couple questions. So would we want to copy a .env into a container image? Yeah, you can do that. And I think Yeah, I do that. I will have an example that shows that when I add a database in later. You could also specify environment variables lots of other ways. You can specify them in arguments and stuff like that. And then there's also a question about Azure Container Registry. We will be using Azure Container Registry with this container soon. Okay, so it built the image. And we can look, I also have the Docker Viz Code extension. So I have the Docker Viz Code extension thanks to this line here in my dev container, Viz Code Docker. So we see the cute little whale, and we can see the images. It has built Flask app, and there is the latest tag there. That's the one it built. Cool. So now the next step is to run that image. So here is the run command that I can use. I'll also show how to do that with the Docker extension. So I'm running it, and I'm specifying the image name to run. I'm also specifying the ports to publish. So what we're doing here, we're saying there is this port 50505 that's exposed inside the container. We want to forward that port inside this environment, so that we can actually, hit it up in our code space. Or if we were running this locally, then we'd be able to go to localhost :50505. So we're forwarding the port from the Docker containers, network interface to our host machine's network interface. All right, let's try it out. Dun, 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 moment of truth. We have a lot of moments of truth today, I suppose. There's a question about entry point versus, we're waiting for this. So this should be actually running that now. So yeah, there are two different ways to specify the entry point command. You can use CMD, or you can use entry point. And the explanation I saw for that is that entry point is easier to override. And I actually do have, I think maybe in today's example, I do actually override the entry point for development versus production. So I think it's generally better. My experience, I think, is better to use entry point because it can get overridden via a mechanism. But they are really similar. So sometimes you'll see CMD used instead. Oh, I think it opened. Let's see. Let's try it again. There we go. Yeah, there we go. It's loading. So this is the containerized Flask website. It works the same as our not containerized version, but that's good. That's good. That means everything is working as intended. So that is with the Docker run command. You could also do it using the Docker extension here. If you prefer using an extension, you just right click on the latest tagged image and then click run. But you might need to specify the ports to publish as well. So I like to use the command because then I can pass in other things as well. Sometimes I like to do that. All right, so it is running. That means it's time to actually deploy it to Azure. So how can we host this containerized Flask app on Azure? We have our diagram again that show the top 4 options. And you actually can run containers on quite a few of these. So you actually can specify your own container for Azure App Service. We, at least internally, call it the bring your own container option. It might be called something else externally, but there is actually an option to bring your own container to App Service. So if you like App Service otherwise, but you want to be the one passing in your container image, you can do that with App Service, and you would just have to give it the right credentials to be able to pull the image from wherever you're hosting it. I haven't actually done that myself, however. What I usually use is Azure Container Apps because it's kind of like a wrapper on top of Kubernetes. So you get some of the nice aspects of the scalability of Kubernetes, but you don't have to deal with all the management of it. So they're doing all the management for you. So I like to use Azure Container Apps. I find it's pretty easy to deploy containers to there. So that is what we're going to use today. But you do have, as of now, you have at least these options. There's also other options like Azure Container Instances. There's many ways to deploy things onto Azure. So here we go. So if we're going to do a container app, what we have, this is what our architecture is going to look like. So we have to make a container apps environment, and that manages the container app. We could actually manage multiple container apps inside the environment if we wanted them, have multiple apps talking to each other inside the same network. But in this example, we only have a single container. So we're going to have this environment managing a single container app. Now that container app is going to pull the image from the Azure Container Registry. So the first step is actually going to be getting that image into the registry so that the container app can pull it from there when it needs to run a container. And you could use other registries as well, but since we're on Azure, it's pretty easy to use the Azure Container Registry. All right, so if you want to follow along on this step, I do have a version ready to deploy. So you can grab this version if you'd like to start from this step here. I'm also going to just try it with the one we've been working on. And yeah, you should be able to do it in Codespaces, VS Code with dev containers if you're not on an M1, or just locally as well. So how do we deploy to Azure Container Apps? I'm going to show two options. I'm going to show Azure CLI, which we haven't used at all yet today. And I'm also going to show AZD. And I think I'm going to try to speed run them with each other to see which of them can go faster. So actually, with this one, let me go ahead and I want to open up a code space for this one. So maybe we can speed run these two against each other. Let's try that. Okay. So first, let's look at how it's going to happen. So to use the Azure CLI, we do need to have the Azure CLI installed. So let's see if I, installed that in my dev container. So I'm going to look at dev-container.json, and I see that I added it as a feature with the container app extension. So it is already installed in here. So if I type AZ, we should see that AZ exists. Yeah, so we see AZ exists, and we see all these possible commands that we can run from AZ. And we're going to be using the container app. Lots of things you can do with the Azure CLI. It's really helpful to have the Azure CLI. I use it all the time, even if I use AZD as my main tool. So the first thing we do is log in. So I'll go ahead and log in now. That's not going to be part of the speed run. Let's see. So actually, I need to log in with the device code. So I'm going to, since I'm in Codespace, I'm going to use this AZ login use device code option. Okay, and I'm going to do it for my personal account since my second factor is my webcam. And now I enter the code displayed. An account. Am I trying to sign in? Yes. All right. So it says I'm signed in, and I go back here and I see the JSON response. This is something you'll see about the Azure CLI, is that it responds to everything by default with JSON. So you'll get very used to just seeing JSON in your shell. So I'm now logged into this code space using the Azure CLI. Now I'm going over here, and this one is still building. So we can't log into that one yet. So I guess we won't speed run it. We'll just start on this one. So the first thing we're going to do is create a resource group. So remember, that's like the folder to hold things. So I'm going to use AZ group create for that. That's not what I want. I want the command. I think I actually already, did I make this group? Oh, not in the personal account. So there we go. It made the resource group. If we go and check in the portal, we should see a new resource group. So I'll click on resource groups, and let's see, what did we make? Flask app says succeeded. And Flask. There it is. Okay. So here is our resource group. It has nothing in it yet. Now we're going to create all the resources and deploy the app. So the reason I'm going to use the Azure CLI first here is because there actually is a single command that you can use that creates that whole architecture that I just showed. So it's actually going to create the container registry, create the apps environment, create the container app, and bundle up the image and build it and send it to the registry. So it actually is a pretty nice experience to use this command. And I think it's pretty comparable to AZD up. So it's AZ container app up. We specify the resource group. We give a name to everything we're making. And then we also specify which port is going to get exposed to the outside world. And then we tell it what it's going to upload. So we're just telling it to upload the whole project. All right, so let's try that. Okay, that's going to take some time because that is doing a lot, right? It's creating all the architecture, doing all the provisioning, doing the deploy. So now let's go over here. And this one, we're going to try AZD. So to start with AZD, we're going to do AZD auth login. And once again, do a device login. I do very much love doing device logins all day. I got used to it. Okay, so doing the device login. And are we trying to sign in? Yep. Cool. We come back and it says we are logged into Azure. Very good. Now we're going to do AZD up. New environment name. So we're going to call this like Flask Container AZD. And select my subscription. Select my location. And now it starts, first it's going to do the packaging. And in this case, the packaging is actually building the Docker image. So both these tools are doing the Docker build step as part of this process because that's necessary to have the image to send up to Azure. And it actually can be surprisingly tricky. The first time I tried to host something on Azure Container Apps, I tried to do it on my M1 machine, but then I discovered that I couldn't deploy M1 images on, Azure apps because it was expecting the different architecture. So I had to learn a little bit more about how to vary the architecture. So it is, these commands are taking care of all that for you. So let's see. So that has, so that one actually has already made the image and it's got a tag. And so that's what is in the registry. Okay. And now it's going to create all the architecture. And let's see how we're doing over here. So one thing about the Azure CLI is that it doesn't give you feedback. It doesn't give you very much feedback. So I don't really know where it's at, if it's okay. Okay, it gave me a little bit of feedback here. So it did make the resource group. Now it's trying to make a workspace. And it's running. Okay. So I like the feedback from AZD better. And we can see what resources it's creating here. Okay, so there's a request for debugging with, so if you're trying to debug your app while using Docker, one thing that I often do is, so there's big questions like if you're developing with Docker locally, are you rebuilding your image each time, or are you expecting to be able to just, update your code and have it auto update? So it's nice if you don't have to, because building an image takes time. So if you're developing locally, you don't want to have to build the image every time you change your code, right? So what you can do is you can use something called a volume, and you can tell Docker that you want your code to be inside a volume, and to be able to auto reload that. And that way, every time you change it, it is actually going to change in your running server. So I do have that set up. I think where did I set that up? I think here. No, Docker Compose. Okay. Well, this is kind of spoilers because we haven't talked about Compose yet. But this is what I use if I want to be able to auto reload my code, is that I set up the code directory as a volume, and that will enable me to use auto reload and use more standard debugging. I haven't tried doing like breakpoints stuff, but I think we should be able to get that working too. But I should try that. Okay, let's see how we're going here. So we can see that AZD, we are kind of speed running it here. AZD has created all the architecture and is now in the process of deploying, which is actually means just pushing the container image up to the Azure Container Registry that it made here. Oh, I feel like AZD is going to win this one. We'll find out. Yeah, there are different, so talking more about the local development, there are different ways of doing the local development. So Kevin is saying that Kevin prefers using bind mounts. So you can read in Docker, the Docker reference is pretty good. So I think they have a page where they talk about bind mounts versus volumes. I think I was reading this. Here we go. So that has some more information about that. But it looks like they do tend to refer the new, they say that volumes are the preferred mechanism here. So that's what I tried out instead. But, whatever works for you. But we'll talk about that very soon too. Okay, so AZD did deploy. So that's cool. So let's see if it looks like an app. Drum roll, please. See if we hit it up too early again. Yeah, and container app is still going. It might be that container app is kind of hanging, or maybe had like a network connectivity issue. I had some issues with it yesterday. So AZD won that one. But let's see if it actually, is going to load here. We might have hit it up too early. Give it a little time to warm up. Yeah, I haven't. So the question is about, breakpoint debugging. I haven't tried. So on VSCode Day, I did show breakpoint debugging with Django. I haven't tried doing breakpoint debugging with Docker. So I'm not sure offhand how if it would actually work so well. But if we have time at the end, we could try it out. Or if anyone has done that before, please share in the chat here. Okay, come on, let's load. All right, we can also open the portal and take a look. And we can check, look at logs in the portal too. Oh, of course, I need to go into my other portal over here. All right. Okay. All right, so here we can see everything that got made. We're going to look at container app. And we can look at the, look at revision management. And actually it looks like it's still in the process of getting up there. Okay, let's only check containers. Yeah, I think it's still going. Okay. Traffic 100%. Oh, we can also check, let's look at the console logs. So one thing about container apps is that the debugging is a little trickier than app service. So sometimes it'd be hard to get the logs if something isn't quite working. That's probably what we found to be the most difficult. But this is the kind of feedback that we give back to the engineering team. We were like, hey, this is really cool, but debugging needs to be easier, right? Like how do I find out, why it isn't quite, loading, right? What is going on there? Okay, let's see. Containers. Dun, dun, dun. Okay, still provisioning over here. And system logs, containers. I think we already checked these. Yeah, it doesn't have any logs yet because it's not up. Okay. All right, well, we're going to give that some time and then come back to it because we do have a lot of questions about, about how we use Compose. So let's move on to Compose and then come back and hopefully it will have loaded. Oh, there it is. Wait, is this it? Wait, where am I? Sorry. Wait, okay, I'm going to give it one more, try and hit up one more time. And if not, move on to talking about databases. Okay, yeah, that's still provisioning. All right, so we need to work that out. And then once we get it working, we will take down those resources as well. Okay, so let's talk about accessing databases from containers and talk about Docker Compose. That's coming up quite a bit in the chat here. So we're going to be looking at this Flask app that has a database and it is already running on container apps right now. So you can see like the container app can take some time to load up because of the tier that I'm using here. So wait for that to load. And then if you want to follow along with this, here is the repo. Let me put the ACA in the chat. Okay, and yeah, here is this survey. So this is a survey app, so you could go ahead and fill out that survey so we can find out about people's Docker experience. I already asked a few people to fill it out, but that is what we're making is this survey app. So it is a Flask application that uses a Postgres database. And this is how you can follow along. I just posted that in the chat already. So yeah, how do we persist data in containers? So you can write data to a container's file system, but that has a lot of limitations. If you remove the container, like you stop the container, take it down, then the data is gone. You don't have access to that data. If you want to move that data from the container somewhere else, it's pretty difficult to move the data because the whole point of a container is environment, and now you're trying to move stuff out of the container. That's not particularly easy to do. And then also container storage drives tend not to be optimized for storing data. If you're trying to have a performant database, you probably don't want to be using a container storage drive. So there's lots of reasons why we really do not want to be storing data inside a database inside a container's file system. So instead, you should somehow store it outside the container. And we're going to find that we use a different way for doing that locally than in production. So we're going to use locally, we're going to use what's called a volume. And we were also talking about this in the chat earlier. So a volume is a directory on the host machine that is mapped to a directory in the container. So the container, kind of thinks that it's inside the container, but it's actually coming from the host machine, and it's kind of earmarked on the host machine for being shared with the container. And that's what we're going to use when we develop with databases locally, is we're going to tell the database to use a volume to store all its data. And that way, if the container goes down, we still have the data because it was actually stored on our host machine all along. So how do we do that? First, I'm going to show the slow way of doing it, and then we'll do it the better way. So let's see. So let's open up this code space and also check the survey. Let me see, one person entered it. Thank you. Let me restart this code space. So this is going to be using Docker commands in order to run Postgres in the local environment. We'll wait for this to load. And also just check on our app. Okay. So this code space also has Postgres set up. Wait, which one? Where are we? Yeah, Flask container app. Okay. Sorry, we're actually going to create the Postgres right now. So first we're going to create a volume. So we use Docker volume create and we give it a name. And let me allow the clipboard. And once we create that volume, we can look at the Docker extension and we actually see it over here. Let me make this bigger. We can see that we've created this volume. So we have this volume. Now we're going to create a network. And this is going to be the network that the Postgres container and the FastAPI container communicate over. So we're going to create a network just for them to communicate over. And we give that a name. And then we can see that network has been created here. And then finally, we're going to run a Postgres container using that volume and that network. And we tell it where the volume is going to map its data to. And this should map what the Postgres expects. And we also are passing in some environment variables. So there's a question about, environment variables. You can, specify environment variables in the run command too. So sometimes that makes sense. That's what I'm going to do in this case. And now it's going to pull the Postgres image. It's just pulling the official Postgres image, pulling that locally, getting all the layers. And it's going to run that as an image. So now we see that show up here. It's running under individual containers. We also have the Postgres image. And we also gave it a name. So it's named DB. And we're going to use that DB name in order to communicate with this over from the FastAPI. So there is our Postgres container running, and it's using the volume. The next step is to run the FastAPI. So we need to set the environment variables in the .env. So I'm going to go back and make a .env and just copy paste. Boop. All right. Then build the FastAPI. Nope, not with that. I'm going to build the FastAPI with this Docker build command. And it's going to build everything in the source folder because that's where I have everything. And this time it's building with 3.11, installing some stuff. So let's see what it is, what's in this Docker file in source. So here's the Docker file I have here. It does install a library that's good for Postgres. And here the entry point is actually a script, a shell script. So I did this to make it easier to override this for development versus production. So in development, I use -- reload because we were talking about how we can have auto reload of our code. So in development, I use -- reload, and in production, I don't use -- reload. So that's another reason to use entry point in your Docker file script, because as we'll see, it's actually pretty easy to override entry point either in your run command or in your Docker compose file. All right, so that went and built that container, and then we're going to run the app container on the same network as the Postgres database. And what you can see here, so I'm telling it the network to run on. I'm telling it a .m file to use, okay? So it's going to get its environment variables from there. I'm telling it which ports to publish, just like before. And yeah, and the fact that it runs on the same network means it can communicate with that Postgres database image container. Okay, so we're going to do that. And here we go. Let's boot it up. Let's try it out. Okay, create new survey, blah, 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 blah. Yeah. So this is working locally. Now that was a lot of commands, and luckily we don't actually have to write all those commands. We can do all that declaratively, and I love to do stuff declaratively. So we're going to use Docker Compose in order to do everything that we just did. We can do inside of Docker Compose. So let's take a look at our Docker Compose. Let me stop this one using the extension, and then take a look at Docker Compose. So in the Docker Compose, we define all the services. We're going to have two services, DB and app. DB uses the Postgres image and gets its environment variables from the environment. It does use a volume for its data, and the volume is also declared down here. And it does have a health check. This is really important to do because what happens is that, you have these two services, and we don't want to start up app until Postgres is ready. Because if we start up app too early and the Postgres isn't ready, we're going to get a connection error when it tries to do like migration or use the database in any way. So we use this health check in order to check to see, is Postgres actually ready for us? And this is a nice way of checking it using the pg-is-ready command. Then we have the app, and here you can see the app. I'm using entry point -dev. So I've overridden the entry point so that I can get that, reload functionality. And then I'm also using volume. So I'm saying the code folder inside the container should map to the source folder inside this code space. So that way, as I am developing, I can change my files locally and reload the page and see the results without having to rebuild anything. All right, and you can see that one thing important is that the environment, we're specifying DB host of DB. So instead of saying local host for communicating with this database, it's actually, we use the name of the running container, which is DB, or the name of the service, DB. So that is what the app is going to connect to locally in order to communicate with the database. All right. So how do we run that up? We can use Docker Compose up. Okay. And that is going to look at the Docker Compose file and see what it needs to build. It actually doesn't have to build that much because we already did a bunch of building with those commands earlier. So hopefully it'll be a little faster. And then once it's got everything built, then it can run things in the right order. So you saw first it got the DB running and waited for the health check to be good, because of this depends on DB service healthy line here. And then it started up the app service and used gunicorn to run it. So now you can open this up and it still works. So that is the better way of interacting with a Postgres database locally, is using Docker Compose.yaml. And you can use Docker Compose for lots of things. So there's been a lot of discussion in the chat about it. So you can use Docker Compose, for easier reloading of your code. You can use it for other sorts of services. So you could have local Redis running, local storage, any sort of local database you could be running inside of Docker Compose. Whatever makes up your application could be in this Docker Compose, and these files can get, pretty fancy. So how do we then host this application on Azure? So here's the thing, is that we actually cannot use Docker Compose for Azure. So that Docker Compose file was only for that local development. The issue is that when you're deploying a container to Azure, you can't use a volume in the file system. You don't have access to make a volume in the file system. You do have some temporary storage options. So you could write to the container file system. You can also have something called an ephemeral volume, but you wouldn't want to use that for a database because it is ephemeral, right? And you do, for permanent storage, there is potentially an option of mounting Azure files to your container, but we think that performance is going to be way too limited to be useful for a database. So that also doesn't seem like a good approach for running, like a Postgres database, where you'd want to have pretty good read and write performance from your database. So basically, you don't really want to have a database in your container app. What you can do instead is use a managed database service, just like the one we used earlier. And, that's going to live outside the container, and your container app can communicate with that service. And if it's all running on Azure, it's going to be fairly fast to communicate. You could run it all inside the same region. You can even run it inside the same availability zone. That's something you can customize when a region does have multiple availability zones. You could specify the same availability zone if you want to really speed up the connection between them. And that should be fairly performant, certainly better than the other options here, like mounting Azure files. So what services can we use? Well, we talked about this earlier. There's lots of different Azure database services. There's Cosmos DB if you want really nice horizontal scaling. There's Cosmos DB for Postgres. There's Cosmos DB with MongoDB. The one that I'm going to use once again is Postgres Flexible Server. It's the one I use the most often. It's the one that I think fits Python apps really well. So that's what we're going to use again. But as we saw, we've got lots of options: MySQL, Maria, Mongo, whatever you need. So this is the architecture that we're trying to create here. Is a container apps environment with a container app, but this time the container app is going to connect to that Postgres server. Maybe we could actually use a VNet. In this case, I'm not going to set that up here. We're just going to use username and password. So how do we do this? I'm going to use AZD. As we see, AZD is really nice for deploying lots of resources at once. Let's see how it works for this. So we'll just go back into here. Let me just make a new terminal. Oh, I'll just stop the container. Stop. Okay. All right. And then let's check that we have AZD. Yes, we do. Let's see, are we logged in yet? Not yet. We're going to log in. So we'll go ahead to use the device code login, because this is a new code space from the one we did before. And yep. All right, very good. Retrieving subscriptions. Okay. And then we're going to do AZD up. And this time, flash surveys, May 2nd. Okay. As your subscription, US. All right. So it is building now. All right. And now let's see how our deploy went from earlier. Okay. We got the dreaded stream timeout. Oh, that's the worst. Let's try it again. Container app still running. Okay. All right. So this one is running there. And okay. All right. So we're going to wait for that to run. And we can take a look at how we're using AZD to do this. So let's look at the azure.yaml file. And here the services, it's specifying the source as the project folder. And it's Python language again. It's a container app this time. And we also specify the module. This actually corresponds to a bicep file. Because in this case, as AZD actually has to do kind of a multi-stage process where it first needs to create the container registry. And then once the container registry exists, it can, put the image in that registry and then use that image as the image for the container app. So we have to do this multi-stage bicep setup here. So we look at the infra, we're going to see a main.bicep, which has most of the stuff we want. And then web.bicep is where we declare our container app. So in this one here, we can see this is the container app. And it has some environment variables like host, user, name, key vault. So actually I am storing in this one, this is worth pointing out, I am storing things in key vault. So I am storing the password in a key vault. And then I retrieve that in the settings.py, I believe. Let me see where our code is for settings. So in production, I import the Azure Key Vault SDK and use that in order to get the secrets. So if you are dealing with, want to have secrets in your container app, this is one approach, is to actually use the Key Vault SDK with managed identity. So this is using, you see it just imports default Azure credential. So I've enabled what's called managed identity on my container app, which means that my container app code can actually authenticate to any Azure SDK, as itself as the app. And in this case, it's authenticating to the Azure Key Vault and using that in order to retrieve secrets. So that's what I do for container apps. All right, and you can see it is creating everything here. Oh, it did say a little failure there. That's interesting. We'll see if that affects things. And then this one is still loading. Let me just look and grab a container app that I deployed earlier, because I usually have a bunch of these. So we can go ahead and look for container apps. And what is one? Flask ACA. That looks like one. That looks like one. Is that the one we just did? Flask app delete later. That looks like a classic. Yeah, so I'm using, the question was managed identity with Docker Linux. Yeah, so this is deploying, deploying a Docker Linux container. And I'll show once again how I did the the managed identity. So here I'm actually using a module. So this is one way you can organize bicep code, is you can make modules. And so we have a common set of modules that we use across our apps. So what you can see here is that we're using some conditions here, but I'm using system assigned. So if you say identity system assigned, then that will mean that your container app is using managed identity. Feel like none of my container apps want to load today. I ran my personal website off container apps for like 6 months, and that worked pretty well. I then decided that it was actually cheaper just to use a static web app, and so then I just moved it all to static web apps because, you know, why go through the effort of a dynamic web app if it's really just static content? And that's even, you know, cheaper and a better use of cloud resources. But I did run my personal website off of Azure Container Apps with a CDN on top for about 6 months. That was fairly cheap as well. I have actually a blog post about comparing, so price off with container apps. I think that's what, okay, there we go. So hosting Python web apps on Azure, a price off. So this is where, you know, I looked at the different ones I was running. So if you're doing, you know, kind of smaller things, hobbyist things, this might be kind of interesting. This was just my experiments on my personal account here. Let's see. All right, let's see. What are we doing here? Okay, so that one. And then this one, oh yeah, okay. That was just me picking a bad name. So I need to update my bicep. Some of our resources are very picky about naming, and Key Vault is actually pretty picky about naming. And yeah, I picked a bad name. So I need to I can fix my bicep so that it doesn't have that issue. Let me go to this and Key Vault. Where is it? Key Vault. Here we go. Key Vault name. Okay. So its name is this. We're going to place all the hyphens with empty strings. Okay. And let's see. Let's see if that's valid. Let's see if that's going to be valid. And then what I'm going to do is create a new environment just to start it over. Flaserv 2. Okay, and then I'm going to select that new environment, Flaserv 2, and then AZD up. Okay, East US. All right, let's see if it. I think I wrote, no, I didn't write the bicep correctly. Okay. All right, we'll just use single quotes. replace this. Okay, let's try it again. Yeah, I actually use, in terms that we were talking about static web apps and pricing, I use GitHub Pages for so many of my applications. I think that's totally cool. If you don't need a database, you don't need a backend, and you just have some cool static content, JavaScript, very JavaScript content all in the client, and then GitHub Pages work, then that's great, because that's free. That's a good use of cloud resources, like not doing unnecessary, calls to a server. So I have a ton of stuff on GitHub Pages. And I guess, the advantage of using static web apps over GitHub Pages is that you can do, pretty URLs, and you can use templating languages and stuff like that. So that's what I use for my personal website. All right, so now this is redeploying, and hopefully we won't run into that key vault name issue. And what was I looking for? Just getting stream timeouts everywhere today. Let's see. Start worker process 20 minutes. Docker entry. All right, and this one is the Flask app with Docker file. Should be running this. I think I might have some debugging to do. Okay. All right, so as all that stuff is deploying, I think what I should do is put out another blog post about debugging Azure container apps, like Python ones on Azure container apps, because it's very cool when it works, but when it doesn't work, it can be a little bit of non-obvious how, like, where to look in the logs. And Jay and I have worked on it together because we worked a lot on the PyCon Azure container app sample. So I think that would be a really valuable post. All right, so let's just talk about additional slides here as things are deploying. So everyone just watch that the whole time. So remember, if you are deploying any of these things, remember to take down your resources when you're done. So if you used AZD, then you can just type AZD down. You can also just go to your portal and find the resource group that you want to take down, and then click delete resource group. If you want to find more examples of containerized Python, we have a bunch of them in the AZD's template gallery here. So what you can do is select Python plus Azure container apps. And there's a bunch of good ones here. Here's one that uses MongoDB. I know some people are fans of MongoDB. This is actually, I think, the one we're working with today. That's just it's a Flask API. So if you're specifically looking for an API versus an app, that's a Flask API. This one is Flask Chart API is really cool because it actually is generating image charts like this. And this one I put a CDN on top so that we're not repeatedly generating images that we already generated before. So if you want to see how to combine a container app with a CDN, and this is the same architecture I use for my personal website that worked really well and ended up being pretty cheap. There's a simpler example of a Flask container with a CDN. So that's pretty similar to the Chart API, but just simplified a bit. We have the Flask Surveys container app. That's the one that is being deployed right now. So that's a classic one with Postgres database and Key Vault storage. We've got some examples here that are from other people at Azure. So this example using Dapper. Dapper is a way of, I haven't used Dapper myself, but it is a tool for running lots of services together that can communicate, and trying to make it really easy for that. And it also has easy pub sub if you're interested in that. So there you see an example where it's using Azure Service Bus with pub sub and container apps. So there's a bunch of Dapper examples there. Okay, and what is still, okay, going on here? And there's a few more resources. So we have, this one about an overview of all the Python container apps options in Azure and some general tips. So you can see deploying to app service, container apps, or Kubernetes. Those are, the top 3 I'd recommend right now. And we also have other articles about hosting Python apps on Azure. And as mentioned, we do have our PyDay survey. We'd love to know what you want to see. I definitely see that there's a lot of people who want to see more about debugging in Viz Code. And, I wish I was more of an expert in it. So I do know, what I showed at Viz Code Day with Django debugging. And I've done like Python and C debugging. But I don't use the debugging functionality as much as I should. So I am going to personally be working on that. And yeah, I think we're getting a lot of timeouts on our container apps today, unfortunately, which makes me sad because I love at the moment when it works. But we've had a lot of demos today. So, we got pretty far and got a lot of those demos actually working, which is always awesome. So we'll see if we get any of them deployed while we're still here. So see some questions. So what is the difference between GitHub Container Registry and Azure? That's a really good question. I actually discovered GitHub Container Registry just a couple days ago because I was looking for cheaper options. So the Azure Container Registry, it's not that expensive. It's only it depends on how many images you have, but at the cheapest tier, it ends up being like $4 a month. So if you're actually running, a production thing off of Azure, $4 a month is, or however much it ends up being for your number of images, but that's not very much. But, for me, I'm trying to find stuff for workshops where I don't want people to have to spend anything at all. So it turns out GitHub Container Registry is a less expensive just because they do the pricing a different way. And, I think you get a certain free amount up to a certain point. So I've been told that this is less expensive. So if you're just, trying to come at this from a hobbyist or an education perspective and you don't want to spend the money on the Azure Container Registry tier, then this could be a good option. What it means is that you need to build and upload to GitHub Container Registry. So you could do that. I think a very popular way of doing that would be using a GitHub action. So you can imagine that on every, push to main or every push or pull request or whatever, you would have a GitHub action that would, create the image and then deploy that to GitHub Container Registry. I don't know if Aaron is still in the chat, but I know Aaron is a fan of that technique and has used it. So yeah, I think this could be a really good option. And of course, you could totally have Azure Container Apps pull the container image from GitHub Container Registry. So you can really mix and match these things. They're all these container related offerings are designed to be mix and matchable. So if a particular registry works better for you, but you want to use Azure Container Apps or vice versa, you can totally do that. Let's see. Another question is, what is the difference, or can you customize AZD down so that it leaves some resources up? Good question. We can always run AZD down help in order to see. Oh, I think this actually deployed. I'm kind of nervous to click on it. Oh my gosh, it worked. Yay. All right. I'm happy that, and this is actually the most complicated one. Well, look, our very complicated container app worked. So remember, this container app is using managed identity to pull secrets out of the key vault in order to connect to the database and, use those secrets to connect to the database. So there we go. It did deploy. It did work. And yeah, I'm not sure what happened to the other ones. But this is with AZD. And you can see everything it made and see the deployed endpoint. And the question was about AZD down. So let's just see AZD down -- help. And what we see is the example, the things here are we have -force so that it doesn't prompt, -purge. This is necessary actually for key vaults, because on Azure by default, it does this like soft delete, but then you can't recreate that key vault later with the same name. So I always like to use purge so that I can recreate it with the same name later. It makes sense though that they try not to delete it. They do a soft delete by default. But yeah, there's no customization here that I see. If you think that's something that would be important to development workflow, then you can always file an issue. The AZD team has been really great to work with, very receptive to issues. I file issues probably every day of the week because I do use it so much. So if you're using AZD, they would love feedback. So please, hit them up in the issue tracker. Let them know if you run into anything, or if there's something that would make AZD more compelling for you. The team would really like to hear, because they want to just make a really nice developer experience, right? And that's why I use AZD, because I like this experience the best out of all of them, in terms of it's generally the most replicable. I can see what's going on. I can pass it off to someone else, and in theory, they could run the same command and have it deployed. And that's the goal. That's the dream. Another question is, do you offer training, whether via Microsoft or other service providers? Microsoft has lots of training on learn.microsoft.com. That's our general place where we have documentation, but also we have tutorials. Like there's a Django tutorial on here even that's not even specific to Azure. And so I would definitely check there. There's also certifications. So that's if you do want to, formally show that you know a particular bit of skills. I haven't gotten any certifications yet, but I do want to, because I think that would be really, really fun. And I heard that some of my colleagues do have their certifications, so now I'm jealous. So I'd probably get, the Azure Fundamentals certification. And so yeah, there's that. I think sometimes there are actual video trainings, but I don't know a lot about them. I'm pretty new to Azure. I only started in May. So I have more to learn as well, but I see some links in the chat. So maybe there'll be more ideas there. All right. So let's see. Yeah. So that was our last slide. Okay. And we got a container app up using AZD, and it was the cool one. So I'm happy. Any additional questions? And yeah, thank you all for coming. It was, we covered so much today. Was anybody here the whole time? Obviously I was. Was anybody else actually able to spend your whole day here today and take in all this Python? And this is recorded, so I think most people couldn't. So this is recorded, so you'll be able to go back and watch it. It'll be on the Microsoft Reactor channel, and the link is being shared. And you are always welcome to look at the slides, and I shared them throughout the day, so I'll keep those slides up. They have lots of links in them, and you can always tweet at me or toot at me or whatever if you need any follow-up things that you've lost the link to. Oh, we see lots of people were here all day. Wow. Awesome. Very cool. Well, hopefully we'll do it again in the future. So answer the survey to let us know what else we should be offering. And, we want to connect more with the community and find out what you all want to hear about. Because here's the thing is, like, we're always learning all the time too, right? So after this, we're going to go back and be like, okay, we need to talk more about debugging. Okay. All right. What's the best way to do that? Right. So this is a great opportunity for us to learn, what are the rough edges in the Microsoft projects? What can we teach more? And then what can we just make better in the products themselves, right? Making it super easy to deploy FastAPI to app service, for example, right? Or to make a launch.json for FastAPI. That's the kind of thing that we want to figure out how to make better for Python developers, so that we can all just be productive programmers and spend our time doing the fun thing, which is, writing apps that do cool things. All right, cool. Well, I think we did it. Thank you, everyone.